Hello everyone, welcome to another stream. How are we all doing? Welcome, welcome, welcome. Ransel, I see you in there. I accidentally deleted my editor config, so had to rewrite it yesterday. Sounds like a chore. But I guess, did you have a lot in there? So today's an exciting day. We're wrapping up on the UI rendering code, which means in the next streams we'll be doing basically writing the UI code itself. We started with rendering because we decided to flex our muscles with the GPU abstraction we've got, the compute only GPU abstraction. So we've just been basically drawing shapes with sign distance fields and things. Hey there, Ruse, and hey there, I completely forgot to pronounce your name. Oh my days. Damn it. Is there you remind me? I need to commit it to memory, but thank you. RCR and Cranston. That's it. Cranston. Got it. Not confusing at all. But anyway, welcome back. Welcome back. So, final stream of optimization. It's going to be beautiful. So last stream we basically, this is the test scene, and then these are the performance results. So we basically we tile out this whole image and we bin a draw command into a tile basically, and then so that we have a tile. We have a shader which bins a draw command into a tile. So it goes over all the tiles and all the draw commands and figures out what draw commands fit per tile. And then that way, if we render a pixel on the screen, we only have to go over all of the draw commands that are in that tile. So it's a way of, instead of going over all of these 13 different draw commands, we can just go over the one for that pixel or that tile basically, right? So it's a way of like grouping data and filtering stuff out, so there's less to process per pixel. So we have that tile, this one which bins it per tile. So this will grow as you increase the number of draw commands, which we'll be testing out later today. And this one is the actual UI render, which goes over all the pixels in every tile and just renders based on that list. So we're going to be trying to make these numbers go down. How big are the tiles? At the moment it's 8 by 8, but I'm thinking about increasing them to 16 by 16, and we'll go into why that is when we get there. So yeah, it was at 4.5 ms. We brought it down to 0.4 ms. So that's a 10 times increase. But as you see here, there's a clear shader. So that's clearing the whole screen. So we're still 10 times. So essentially you can think of that as like a baseline of like, that's the best you can do, right? So we're kind of like 10 times slower than the best you can do. So we're just going to try and get closer and just see how close we can get. Hey there, Game Legaz. Welcome. You work for any comp? Yeah, I work for a media molecule. That's where I work. I'm an engine guy. Well, technically I work on the graphics team. I picked that needs to be obscure so it could be anonymous on the net. Beautiful. Yeah, it's true. So we also got this, this is a visualizer. So you can just enable the thing in the shader, compile it, run it, and this is all the different tiles, right? This is 8 by 8 pixels on the screen, basically. They're the individual tiles, but we're going to make them bigger because I think that's going to be an optimization. And this is a heat map of how many draws, where each tile is rendered, and we basically just see how many draw commands are in the tile and make the color more. So it's purple, it's blue. Blue is cold, red is hot, so we want it to be as cold as possible, right? Because the hotter it is, the more expensive it is. You want to blame Git? Because it complained about having another repo. Because it complained about having another repo as instead of a submodule. Oh no. Yeah, see, Git is a very dangerous tool. if I'm working on a solo project that's not public, I typically like to not put it in Git and just copy and paste the folder somewhere. Because I'm really not a fan of source control, basically. It's so easy to make mistakes like that. I guess if you use a UI, it's a bit easier, but then you don't learn the Git properly. But yeah, so we're going to start off today with a little bit of an easy task. I've had some on the Discord, someone posted, just had a look at the code and thought they found a problem, so we're just going to look at this first, then we're going to add dispatch indirect support, which means then we can let the GPU decide how many tiles it needs to dispatch, and then so that means we can dispatch less tiles on the screen. So see how this colors the whole screen with tiles? Instead, it only color the portions of the screen that actually have a draw command there, and any empty space would just be ignored. So that's what we're going to be doing next after this thing. But yeah, I hope everyone's having a good weekend. Hey Sockham, how you doing? You're gonna call Bug Busters? Ooh, yeah. I need them all the time and see, all this unsafety everywhere, But how's things going, Sockham? How you been? How you been? So I think you found a bug in the Vulkan backend, which is probably true. We just crammed this thing together. There's actually, we've got to go back into the Vulkan backend and make sure it works across many different GPU setups. Because I just like hard coded the physical device selection as an example. We don't check for features yet. We just, So, but this one's saying something to do with the memory, I think. So, where you change the flags to create info, but it's completely redundant because create info leaves the scope and cannot be accessed again. Oh, scope issues. So obviously if optimizations are turned on, that's probably more likely to fail, isn't it? Oh, that's for shaders, give me. GPU. Yeah, what are we doing there? Oh, what's this doing? Oh, okay, so this is just stuff that's left in. I think I copied and pasted it from somewhere else. Suppose you wanted to call get buffer device requirements, the memory type bits usage. Good point. That is a good point. Yeah, because this fills out the memory requirements information. Yes, we want to duplicate that a few times. Oh. Right, so it's getting memory requirements for buffers. This one is wanting to say storage buffer bit, transfer source, that's transfer destination. So this will be for the upload buffer, right? Because it's transfer source. Right, whereas these are readbacks. Readback buffer. And that's for standard buffers. Huh. Yeah, standard buffers want transfer destination because you copy from the upload to it. Yeah. So that's a good, oh my days. That is right. I can't believe I missed that. That was a good catch there. Just thank Glorious Sir. We was missing the VK get memory requirements thing, weren't we? Damn copy paste. Now let's just make sure it was correct, right? So let's just recompile it, give it a run. Obviously it's landed on the right heap. There you go. Awesome. Yeah, Glorious says in some glorious work. It's amazing. Is the code open source? So the code is available. If you're a Twitch subscriber, you support via Ko-Fi, which is nicer for me. Then you can follow a link to the Discord, and there's instructions basically on how to download the code. Yeah, so read my code. That actually uses two compilers. We've got a custom shader compiler, and we use Clang as well. So we've got a custom C compiler for shaders. We compile all our shaders, and then we compile the code. And that's all done all the time. Until we need a more complicated build system, we will. So we just do single compilation unit right now. We don't really have a lot of code at the moment. Hey there, Not So Red. Welcome. Good to see you. But yeah, if you follow that link there, there's instructions on how to get the code when you're a subscriber or member via Ko-Fi. Runs on Linux and Windows. Have to have an AMD or an NVIDIA GPU. Somewhat newer one. While languages such as projects, man, yeah, they are, but they're fun. Have you been able to look at the usage of that deprecated function? Yeah, there is that one. I haven't been bothered, to be honest, because it's just deprecated, which means it's emulated by the kernel. Although it is, yeah. I should look at it at some point, but it's fine. Oh, also the comma as well, yeah. The comma would be fine, I think. Yeah, right. So should we take a look around just to double check, because there is code below. I just want to make sure that these memory type indices are not the null buffer, null image. Yeah, that's all creating the stuff, right. Yeah, I think that's all good. That's fantastic. Is there a specific reason? Yes. That is because Intel doesn't support. So in our custom compiler, we've got like these sort of like types with textures, and if you're using Intel, you have to provide the format. You have to provide like format 888 RGB or whatever. I think it's just 888 maybe, or RGBA. Or I think you have to do something like this, right? And that, like, I started adding that support in, and then it kind of got a little bit complicated, made the code more complicated, and then I just decided to be like, I'm just going to wait this out because the future of GPUs probably won't need this. So I've decided to just wait. But C23 has attributes, right? So because C23 has attributes, potentially then, what we could do is maybe have attributes, like, because we've got a custom compiler, we could maybe have a custom attribute that goes above here instead and puts the format in here. And you only need that if you want to support Intel, right? But yeah, it's all a big, like, load of crazy. I'm hoping that the new Intel cards don't have this problem, and then we're just not going to bother supporting older Intel cards. Because by the time we're probably done with this game anyway, we'll just be on the newest wave of hardware, so be fine. We'll see. Yeah, the compiler is open source. It's on GitHub. Do I recommend C23? I don't know. They've done some cool things, right? They've added type of. They have made it so switch case statements. Switch case statements are, they have blocks, implicit blocks now. They've added fall through, right? They've added a few things, but then they've done stuff like add auto, which basically just like people are going to start putting auto in everywhere instead of types now. So you'd be like harder to read and understand what code actually is. And they've gone and added null pointer in instead of just standardizing what null means, right? They could have just said, hey, null is literally void zero like that. But they've made a proposal where they're like, no, null pointer is, they've added null pointer t now as well. Is null pointer t, which implicitly casts at any pointer type. But then we don't have the C++ problem where void implicitly casts into anything. So what they should have done is just standardized on what null meant, because they did some breaking changes in this release anyway. They've done so many breaking changes that they could have just added this to the breaking change, and they didn't. So yeah, because technically null could be defined as 0, it could be defined as 0 UL, UOL, right? It could be like 5 different types, and they wanted to fix that problem by adding a new thing. So that was already done. Yeah, so I wish they didn't do that. But they've done some good things, but then they just do silly things like this. Yeah, and these are cases we need different formats. Are these cases where we need different formats and can't hardcode the format on the level below typical user code? Yeah, so you can't infer it from how they use the texture. Like if you go to SpearV, SpearV spec, there's formats. Like if you program in GLSL or even HLSL and transcode it to SpearV, you have to do these things. We have to actually put the format in, because when they do a store in the Intel hardware, they need to know it. They need to know of the format. When you compile, they need to know it. Yeah, I'm not sure what the exact reason is, but they probably insert instructions in the actual shader code or something. I'm not sure how it works under the hood, but they need to know it in the SpearV code for some reason. So yeah, it's just one of them. So you need to define it in both the CPU side and in the shader. Bananas. So I'm hoping Intel moves away from that, because AMD and Nvidia don't do it. Yeah, they've changed what auto means. That's the other breaking change, right? They've changed what auto actually means. Not that people used auto, but still. Right, so let's add dispatch indirect. So let's go to our super lovely GPU backend API. Dispatch indirect. So dispatch indirect allows you to have a buffer that has some arguments in it, and those arguments are filled in on the GPU. So see how we have these groups, our dispatch groups, that is filled in on the GPU instead, and this allows us to have GPU driven rendering. So we need a buffer, and then you need like a byte offset or something. So we do GPU resource ID. So this would be where the buffer, you call it like arg buffer ID, and then you kind of want to have like an offset, I think, arg buffer offset. So I'm gonna have to go in and check the Vulkan or VK command dispatch indirect. Just want to check that quickly. Oh, they don't have an offset? Oh, they do. Yeah, good. So this means we can put in any buffer, and we can just provide an offset. So it's really wonderful. We'll just do a 32-bit integer, I think. And we'll do U-pointer. Or it should be U64. Yeah, so we've got to fill this in the back end. No biggie. No, I think we'll take in a resource pointer. Something like that. Good. Sehr gut, as the Germans say. Right, so it would just be basically copying the dispatch one. So the way our GPU API works is we just call directly into the command buffer. So can you technically define a format in SPIR-V, for all GPUs, or would that not work? So yeah, you could have we could in the compiler interface just be like, dash format equal RGBA8, right? And then every texture gets that format. Like that's the solution we could do, right? But the problem is people want specific, like especially when you're doing hardcore GPU programming, you want to have different formats in your textures and things, in your shaders. Like you can't just go off RGBA, unfortunately. You could do, simplifies things, but yeah. TLDR, the GPU tells itself what to do. So then we upload the push constants. I actually learned something new about AMD hardware the other day. I found out that push constants go inside the SGPRs. No wonder why the SGPRs have such a big pre-allocation of SGPRs, even on the most basic shaders. Because, if we have 64 bytes, which is 16 D words, isn't it? So that's 16 SGPRs is going to pre-allocate for it, which I didn't realize. So that's something new I learned. Yeah, we're looking at that in a sec, because I think we can optimize our VGPRs. So we do a dispatch, which means I need to do another function pointer. There we go. Let's load that new function pointer from the device. So we need the buffer. So that'll be in arg buffer buffer or backend data. How do we get hold of that again? This guy. What's in here again? We just want the buffer, isn't it? Yeah, we need a buffer from there, so it's good. So we should use that one. VK buffer, fantastic. Then we do the arg buffer offset. Now what we really want to guarantee is that this doesn't overflow this buffer, but we'll do that in the higher end because this is just the Vulkan backend. We'll put all the asserts in the layer above. And then we're going to pass in, that's it, right? Voila. So this is some profiling information because it's got a little custom profiler which literally just dumps it out to the terminal at the moment. And it's been pretty useful. So now we've got this, which means we can now call it from the higher end. So go to gpu.h, I guess. And we're going to go ahead and find dispatch. So we'll copy paste this one, dispatch indirect. We'll pass in the buffer GPU resource ID arg buffer ID. Then we pass in a U64 for arg buffer offset. Do we use U64s or 32s everywhere? Oh, we use U64s here, so we keep using U64. Yep. How to implement the binning? I'll show you that in just 2 seconds when we get this all plugged in. I'll go over it in literally a couple of minutes. Shouldn't be too long to get this in. Right. So all we need to do is copy and paste the previous one. So essentially the way our system works is we can define, then when we do our GPU rendering, we can say our sync code, the way it works is you have to explicitly sync on stuff. So you go, sync, read, write, sync, read, and it keeps track of states, what they're in. Was it last read to? Was it last written to? And if you have like a read-write dependency, it will insert a barrier. So if you get all your resources with read-write dependencies, and it will keep track of that. It's a very simple system because it's just compute only. And it will automatically insert the barrier if you have any ones with read-write dependencies pending, basically. So we insert the resource barrier. That's just a pipeline barrier in Vulkan term. And then we can chuck in the... Now what we want to be able to do is we would need to be able to do a GPU resource arg buffer. Now we want to just do some assertions, right? So do a GPU resource get arg buffer ID. Now, so the assertions are core debug assert that the arg buffer resource is a GPU resource buffer. So, you know, resource must be a buffer. Now the other one is that the size, I think there's a size in there, buffer size. Now the buffer size, this offset, arg buffer offset. Now this, I think it's 3 E32s. So we need to say this plus size of that one, right? Must be less than or equal to the size. So here you're just saying arg buffer offset overflows the buffer, so it goes out of bounds basically. So that's a nice little safety check. Pass in the arg buffer and then pass in the arg buffer offset. And then this one is just basically resetting all the synchronization state back to, yeah, just resetting it because we've done the syncing. So we just sort of update it and then clear them again. Right, very good. So that should be the draw and direct implemented. So now why do we go and implement that draw and direct? So remember, let's hit compile. Look at that, it compiles. So remember when we said we split the screen into tiles, if we enable, this is our UI renderer, if we enable this little visualize tiles, right, what we'll see is a full screen set of tiles on the screen, yeah? So these are 8x8 pixels tiles where we bin, each of them has a 16 element array, and we literally say if a draw command is here, we'll bin it in there, so the 8x8 pixels have a short list that they can go over, and it would be more optimized, right? So with draw indirect, it means that we can say, hang on a minute, if there's no draw commands in these tiles at all, just don't bother drawing that tile, right, at all. So the blue background is actually one big massive draw, but imagine if that wasn't there and it was just a background color for some reason. All these ones don't have to be drawn. So that's what we're going to start implementing first, and we'll have a way to toggle it on and off. So we can do some performance testing basically and turn it, a full screen render. We do really want to have that around as a way of benchmarking how good our shader actually is, right? Right, yeah, I'll get into how the tile binning works now. So how the tile binning works is we literally just dispatch 8x8 local. So each thread in the 8x8 goes over a tile on the screen. So we basically just dispatch across the whole screen, and then every thread goes over every single draw command, and then it just simply checks if how does it check? Yeah, simply just checks if the draw command goes in the tile, and if it does, we append it to the array. So there's an array called tile draw commands, and it's a pre-allocated array which says based on the size of the screen, you've got this many tiles, right? So it's like, and then you've got 16. You've got enough to store 16 draw commands per tile. So we pre-allocate that array. It's like I think it's like half a megabyte. It's not that big. It's like half. Wait, is it half a megabyte? I forgot how much it is. It's either like half megabyte or like 4 megabytes. It's somewhere in between like that. So it's not massive amounts of data. So it's pre-allocated, and we basically fill in that array. We fill in that tiles. So we calculate the start index based on the tile index on the screen. So given the tile index across the whole screen, calculate where its offset is into that array, and we fill it up every time we come across a draw command that fits in that tile, basically. But yeah. Do you not have a struct that describes the indirect command? Size of what would be more clear? Yeah, I don't have a structure, but yeah, that's a good point. It is better to do that, isn't it? Should we do that? So what we should do is this, because it is cross-platform actually, so we should do it. So we'll put it up here. Type def structure GPU dispatch indirect arg. So I call it arg buffer, but really it's args, isn't it? Yeah, if you have any more questions, feel free to ask about it. We can dive into more detail. Oh, the renames. Sweet. Let's get out of there. So what you're saying is there's a dispatch indirect arg. So U32. I don't know. Yeah. I don't know. Maybe. Yeah. It's one of them. Damn it. Because I would be basically saying, I guess, num groups X, Y, Z, I guess. Yeah. Yeah, I'm not sure if the shader will use this structure though. Because I might bind it as like a... Yeah, we'll see. I wonder where I hack it in actually. I might just... I think I'll put it in the same buffer as one of these word buffers, which is just a 32-bit integer buffer. We can pass in an offset, which would be decent. Bear in mind that offset should be 4-byte aligned, isn't it? That's another one. Right, this is good. This one. Has to be 4-byte aligned. Must be aligned to boom. Hey there, Captain Chica. Welcome back. How you doing? Okay, so now we want to fit this thing in. So how do we do that? So I need to find a buffer that we can throw it in, which is probably inside the tile binning shader itself. Right, so the tile binning shader writes out to a couple of buffers. It writes out to this one and this tile list. Right, it writes out to a tile list, doesn't it? Why does that read right? Oh, yeah, because we do this. Excellent. So we already overload the tile list for something else. Because, okay, it's a bit of a waste making another buffer when you're just storing like a couple of bits of information. So you might as well like reuse another one and just stick it somewhere else. So there's this thing called a tiles list. And this is literally like, it's a linear array of tile indices of ones that we need to draw. So I've already gone ahead and done this work. So the tile binning, if the tile that we're looking at in this thread is like, hey, I have some draw command inside this tile, I'm going to then put my tile coordinate in this array so the other shader can just pick it up. Basically. Wait, what is this doing? Right. Store the number of draw commands in this tile. At the start of the draw command, yeah, at the start of the array. That's it. Good. Cool, I nearly forgot about that one. So what we're going to be doing here then is, I think we want to overload this to be something else. So I want to also store those draw command indirect commands in here. Tiles. So we've got a counter index of how many. So that's our insert index that we'll just keep incrementing. Then this one is probably going to be dispatch arg x dispatch y z. So it's kind of a bit hard coded, but you know, gets the job done. So then we'll start the tile indices off at 3. So we've got the start of the array doing something else. Wait, no, wrong one. Yep. Cool. So we've got we have to make sure that we pre-initialize this data, right? So we have to make sure that, yes. So we've got this thing called frame initialize. It just runs one thread and just initializes a bunch of buffers at the start of the frame. So we initialize like the printf buffer back, like set up the cursor at the beginning. The readback buffers that we have, we set those up. But we also have this tile listing where we set the counter at the correct place. So this sets it to 4, right after all of the stuff that we've just put in. So we've got dispatch x, that needs to be 0. Y and z need to be 0. And what we're going to do is we're going to atomically increment x, right? So where we do the counter thing, now we're going to do an atomic add. We're going to add 1 to dispatch x, right? So we atomically add 1 to dispatch x. Wait, why are we doing that? Yes. So our UI renderer has tile size by tile size local dispatch. So it's 8 by 8 at the moment. We're probably going to extend this to 16 by 16, but we'll do that soon. So every group is a tile. So we're going to add 1. So this is like, hey, this tile is used. So we're going to add 1 to it. Good. So that right there should be all we need to do. So I think no, sorry, we've got to plug it in from the graphics side now. So we do dispatch, right? So when we do our dispatch here, the UI renderer, say indirect. Now we need the args buffer. So we used to hard code it here to 3000 odd. No need to do that or 30,000 odd, whatever it was. Yeah, 30,000. We used to hard code it because that was the number of tiles we needed for the whole screen. Or it was actually more. I wanted to test it by doing a bit too much actually. I think it's 26,000 it was. But now this is done in the shader. So we just need to put in the buffer. So the buffer we need to put in is ggfx.ui tile list, because that's where it is. And the offset is at, wait, is it an offset in bytes? Offset in bytes, by offset, okay. So in the shared, we'll say gfx UI renderer dispatch args offset is going to be this times by size of U32. Very nice. That's the offset in bytes, right? So we've got that in a nice little constant. And we can go ahead and throw that in there. Right. So we've just done something GPU driven, which means the likelihood of this thing blowing up and crashing my computer is quite high. So if the stream goes down, I'll be back in as soon as I can restart my computer if that's the case. But hopefully it should work. So let's see. Right. So it didn't even render a frame, which is strange. So let's debug this. So what do we usually get, right? We usually get this. Frame initialize. Yeah. So the way we can look at this is like, well, if I were to comment out this shader, does it run? So is it the renderer that's taking time, infinite time? Right, cool. Very nice. So what we've discovered then is this dispatch indirect for some reason is clogging up our yeah, something really weird is happening. So we just got to investigate why. So we initialize them each to 0, right? Just double check. 0, 1, so they're not overlapping, which is nice. We then do an atomic add 1, and we just add 1 to every time. So if I were to comment this line out, what happens? Does it just not render anything? Right, it just gets stuck still. Have I disabled the Vulkan? Have I potentially disabled the Vulkan validation stuff? Isn't it always on? Yeah, I think it's always on. Yeah, if it has validation, it just throws it on. Oh, debug. Where's that? Right. So we don't have this enabled. Oh, so it's not doing API dump, but it's doing validation. Right. So if we were to like enable this somewhere. Where would I do that? Ta-da! Right. So it's doing a right timestamp. So there's a dispatch 111. There's another dispatch for that number, which is probably the number of tiles X and Y. And then it gets to another dispatch. Oh, Devro, thank you so much for the raid. Appreciate it. Welcome, raiders. How are we doing? How are we doing? Thank you so much. So we're currently working on a UI renderer. We're just optimizing it. It's compute shader only. Custom game written from scratch with no engine. So we're just doing some kind of low-level optimizations here. So if anyone has any questions about what we're doing, feel free to ask away. I'll happily go over. But yeah, how did the stream go? How did the stream go? Hope everything's going good. So we did our push constants, right timestamp, whatever. Then it got stuck. So it got stuck doing the dispatch indirect. And it's just not doing anything. Like it's literally frozen. So it's not anything to do with the shader. It's when we actually call this function here. It goes into here. Does this. And then it's like, I'm going to take an infinite amount of time. For some reason. Why? Do we have to enable it as a feature? Looking good. What's the game genre going to be making? We don't know yet. So I'm currently just getting like some core foundation together and getting like a flexible renderer that I can sort of change and modify specifically for this game. So I'm just getting some basic foundations in and making sure it's all fine. Using compute shaders only, basically. And then we're going to be doing some 3D graphics R&D using, again, compute shaders only. So we're trying to like basically have like a graphics. I want to do like a come at it from a graphics angle first, and then use that to sort of feed into sort of any game ideas basically, and go from there. So have everything ready to prototype basically, and extend. Going good. Started working on a tank. Then people ask me Blender questions, which I love because that's what I stream for. Excellent. Nice. Awesome. You making, I guess, a tank game then? Or has it just got tanks in it? Right, multi-draw indirect. This is not a feature then. You have to turn on. Why doesn't this work? Provided by 1.0, obviously. Why does it hang in the... Must be a valid handle, that is true. Yep, it's all pretty standard stuff. Why you no worky? Right. So let's just run it. See, I was scared to keep it running. So let's just keep it running and see what happens. So my CPU obviously just climbs a little bit, but nothing too much. I guess it pegs a core. Right, validation error. That makes sense now. So the the validation was just like Oh, I remember now. Here's the thing. We've got a little stack trace thing, and this thing runs like every entry in the stack trace runs over the the DLL to get the line number, because that's the way you have to do it on Linux. For some reason, you have to use like read ADDR to line or something like that. You know, ADDR to line to extract out the thing, but the line number with the address. It's weird. I don't know why there's not a good library anyway. So this Kronos library is huge. I forgot how big it is, but it's huge. So it basically takes seconds to just get one line. So when I've got many lines, it obviously takes many seconds. And that's where the problem was. I just got to remember that that is a thing. So yeah. Anyway, so there's a validation error. I've got stack trace for it. Woo. So it's in the indirect. And it's saying that the buffer must be created with indirect buffer bit. Boom. So let's check our GPU API for a minute. Right, so we don't have many arguments, right? And we don't really want to add a flags argument. So you know what we're gonna do? You know what we're gonna do? We're just gonna let all of them have the capability to do it, you know? Tactical RTS with few tanks in it. Sweet. I used to play a lot of RTS games when I was younger. Good times. Good times. I used to play tons of games when I was younger. Right, so all the buffers get it because they do. So this one is for the standard buffer, isn't it? Then these bits are actually wrong. That's a bug. Whoopsie. I'll fix that up. Read back. Right, so the read back buffer technically just wants so the readback buffer one wants transfer destination bit only, doesn't it? Yeah. Right, let's fix that up. Right, so we're running now. Got a black screen, but that is fine because the GPU's not crashed. So this is good. Right, so we can turn on some debugging things. Let me just disable that horrible logging code in the Vulkan backend. Yeah, back when they were still good, exactly. Games are, yeah. So now our shader's been heavily optimized and it's so fast, it's just so small. Right, let's sort that out. So let's enable the visualization to see why this... Right, so not seeing anything on the screen at all. Weird. I'm confused. Do, 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 do. 2 GB file. Maybe it could have been. Yeah, maybe it was gigabytes big. It was huge. Yeah, no, it was gigabytes. Yeah, I remember it now. 1.5 or something like that. Yeah, all of them indirect. Just make them all indirect. Yeah, it's one of those things where it's like some drivers could do something really specialized and optimized, and then you or turn off certain optimizations or whatever, you know. So, but I kind of doubt it on hardware that we want to support. And if it is a problem in the future, we'll just change it. So clearly we're not getting anywhere here in rendering on the screen when it comes to rendering the actual tiles. So I'm struggling to think what this might be then. Oh, because they did times by 0, guys. 1 and 1, right? All you need is 1 in these ones, because if there's 0, then it's obviously nothing, right? So you need x, y, z to be 1. Okay, so let's try that. And we got ourselves the tiles. So now this is where we're going to get an optimization, right? So let's disable that if 0. See, oh, it's if 1 here, the visualizer. So here's our... Oh, you silly thing. Right. So see here how we've got like 13 draw commands. There's technically one in the background, but we're going to remove that one. So we should only be seeing tiles around the actual draw commands now, right? With this optimization. But we'll obviously have ways to disable this because I want to be able to benchmark the shader in a full screen situation. So we'll have you know these compile time things to change. So where's the test code for it? Here's the background. So let's just get rid of the background. Right. So we got rid of the background now. Now let's reduce it down to 0.2 ms. So it's made the capacity. Well, it's increased it by about 1. It's 1.5 times faster because it was about 0.4. Yeah. So now if we enable the debug visualizer, this is where you'll see it all, right? See that? So now the tiles are only being rendered where they're needed. So they're no longer going to start the shader on all this empty space and then check the buffer to see if they've got anything and then realize it's 0 and then go and write out a pixel to the texture, right? So they're not doing any of that. See, it's all dynamic and pretty sweet, right? So that's the optimization. So we want to have a way to disable this optimization. So to do that, what we're going to do is we'll have a little, in this tile binning, we have a way to disable that and run it full screen regardless. So essentially what we want to achieve is this thing to run all the time. So we want to have something like define GFX UI binning disable, or like I don't know. What do I want to do? It's like we want to say we want to say like display all tiles or something. UI so display all tiles, or maybe run all tiles. Enable this to when benchmarking the GFX CS UI renderer. is that what we want to do? We want to enable it the cases when we have a full screen. Yeah, we want to run. Yeah, we want to have. Yeah, when benchmarking the UI render, so a full screen worth of tiles run all the time, something like that. So here we're going to simply enable. Shoot, what's it complaining about? Cool. Right, so that obviously didn't. Oh, or I meant to say, isn't it? Sorry, being a silly bugger. There we go. So it's a full screen thing, which is good. And then we can just turn this to 0, and then we get the optimizations. That. Very nice. So what we're going to do now is we're going to keep it enabled because we want to, again, do some benchmarking specifically for this shader. Very good. Very good. So we're going to bring the background back because the background is our buddy old pal. It just basically puts in a we was using it before, and it will be cheating if we didn't have it, and it basically puts in a draw command per tile. Okay, so the next thing I want to do is test out tile size. The tile size is 8 by 8. It's a good number. Because 8 by 8, if we put it directly on this thing here, okay, which means that the local dispatch size on AMD hardware could be like a native size to like the compute units. Technically it's like a dual compute unit. 8 by 8 is 64 threads. And on NVIDIA it's 32, and on AMD there's 32 threads as well. So NVIDIA can do 8 by 4, and AMD can do 8 by 4 as well natively. And obviously if it's not, you want these to be a multiple of 32. So obviously 32, 64, and anything about 96, I think, then 128. They're all multiples of 32, and that's a good number to use. So the reason why I think 8 by 8 might not be good is that there's kind of two reasons. The first reason is that this is random, right? Okay, wait, let's just do one more note. If we make this 16 by 16, what we're going to be doing is we'll be getting 4 compute units having to execute this. So 4 compute units of wave 64 as an example, or 8 wave 32s to execute this one tile instead of just 1, and it's a larger area, which means you have 8 or 4 groups sharing the same list of draw commands. So there's some caching benefits there, right? So where the caching becomes an issue, well, this is me theorizing here, so we're going to see if that theory becomes true. So we just display these tiles here. The biggest problem is we've got when we're doing this thing here, we're atomically adding and inserting into this tile list, which means every frame is different. It's not, they finish at different times. You don't have any control over that. So basically, whenever you run a compute shader, usually what you'd get is it'll go in order. The groups will dispatch in order, so it'd be that tile, then that tile, then that tile, then that tile, and go all the way across the X, and then go down to one by the Y, which kind of has some problems with caching as well. Usually you want to sort of build up these little, you usually want to sort of like group them 2-dimensionally or 3-dimensionally, depending on what your compute shader dispatches over, and get some sort of caching benefits between the thread groups, or the dispatch groups as we call them. But ours is completely random, which means this one will get launched, that one will get launched over there, that one will get launched over there, because the list that we're making is not ordered. Now we can fix that problem by sorting it, by sorting the list, but then that's another compute shader I have to write, and it's kind of effort. And I do want to be done today. So I don't have to implement a sorting algorithm because I haven't really done one of those before on GPU, so that'd be something I have to learn. But there's a quick, easy way around it. We can increase the tile size to 16, which basically means, as we said, it has either 4 or 8, depending on the wave size, will be launched, right? So if we increase this tile size and times it by 2, it means this 4x4 here, right, will be ran like you imagine. So so it'll run. Imagine it's running in wave 64, so it's 8x8. This one will get ran, that one will get ran, then this one will get ran, and this one will be reran, and those might be running on the same compute unit, and they'll be preemptively switched out when there's like a texture sample or a buffer read where it has to wait. So it might switch out to the other one, and it, all that data might be cached, meaning when the data when the cache line comes in or whatever, it's has that data anyway, potentially. So there's some, so it automatically is bundled it in that Z curve, as they call it. So we should get some caching across buffers and textures, hopefully, and it should increase performance. And also there's less tiles, which means that shader that we're running, so there's a shader, this tile binning shader, so we've only got like 13 draw commands, or 14 at the moment. So if we have 1,000 more, right, presumably this would be times by 1,000, right? I'm not sure how realistic that is. So by reducing the number of tiles on the screen, it should also make this quicker. So there's stuff, it could potentially be improving both shaders, this tile render shader and this one. And so our overall limit to B is about 0.12, but this is like 0.4. Wait. Oh, no, sorry. Wait. That was the debug. Let me, right, let's enable the proper thing. Right. So I want to be is about 0.5, in total. Oh, no. Yeah, about 0.5 in total on average, I would say. This one's is about 0.43 at the high, 3.9 at the low. And this one's about 0.2 to about 0.5. So we'll take, there's a good one. Should probably jot this down. So what we're aiming for, or what we're trying to compare against on average, so we're about 0.5 on average. Then we want about 0.4 on average, and this one's about 2 to 3. So it's about 4, I guess. That's the binning, right? It's 10 times quicker, something like that. Right, so we'll see what those numbers kind of look like. Actually, it's quite easy to remember. 0.5, 0.4, 0.04. Yep. Right. Good. To close that buffer properly. Get out of here. So this is what C does to a man. He now looks like he spent writing a whole new OS for the past 3 months. Damn straight. That's what we do. I actually wrote a whole compiler so we can use C for shader programming, so that's what it does to me. But now we can do cool things. We can use C on the GPU. Yes. So, amazing. Where did my audio go? Let's turn my PC around so I don't nudge the cable. Hey there, Shilo. Welcome, welcome. How you doing? So the optimization is right now, if the stream dies here and crashes, it's because I did something wrong, and so be warned. Let's just check around this constant quickly and make sure it's all used in places which is where it needs to. I think it is. You know, I'm gonna trust past me. This is probably got it. Trust past me. So it crashes. Obviously, past me failed. Hopefully, it doesn't die. Yes. Right. So it didn't die. So now the tile size is 16 by 16. So we quickly just visualize it, and then we'll get to the performance information in a second. So as you can tell, these tiles are now twice as big, right? Which is proper sweet. Proper sweet. And it still looked like it was rendering, so it's good. Sehr good. So now we're down to about 0.47, and it was about 0.5 I wanted to aim for, wasn't it? We're not jumping up. Yes, we are faster. This is actually more stable. The tile render is more stable, because remember I said it does those random allocations all over the place. Well, this is actually more stable now, because it's not presumably jumping all over the place and the cache not being reused. So that theory seems to be correct, right? This number just seems more stable. Okay, so that's good. And this number is also less. It was about 0.2 to about 0.5, wasn't it? Because you obviously have less tiles that you're binning into, right? So that's good. So I think that's a good optimization. So we brought that down now. Okay. What's my reason for my Raman compiler? So if you've done GPU programming, basically it's terrible. If you want to share structures and functions between the CPU and GPU, you have to rewrite it or have some sort of like intermediate language that you compile out into a C header and a GLSL header or whatever. And also if you're going to do cross-platform shaders and go to another platform, you have to like transpile your stuff all over the place. So if I have my own compiler, it means I can just do that from C, right? Share functions, structures. Obviously there's limitations, there's no pointers. Also, if you take a look at the new Vulkan side of things, there's these things called bindless buffers, bindless textures, and in my C compiler, they're a first-class citizen whereas in GLSL and HLSL, they're languages that have stayed around for a long time now, and the ecosystem has evolved so much that they're basically a very hacky thing, and they've just always add some new feature, and there's always different ways to do all these new things, whereas it's just better if they're built into the language as a first-class citizen, in my opinion. So so now we can just pass buffers and textures into the shader via push constants, like they're just data, as opposed to being this thing that's a binding, right? And there's tons of other things that we've done. We've got like a shared maths library. We've got like also, you can get this right, revolutionary, right? Multiple shaders in a single file. For some reason, that's not been a thing ever. What else? There's tons of other things. It's just ridiculous. Like, yeah, like but yeah. Also, yeah. Oh, fast build times. If you're going to compile, multiple shaders, you're doing multiple invocations because you have to put it into separate files, right? They're all because you can't have them in a single file. They're and you're including all the same code over and over again, which means it takes seconds to compile things. But now it's instant, right? Press compile. That's building my game, like all the shaders and my game, like that. So go and 1 second, done. So obviously that'll increase, but we're just doing that every time, and it's quick. So yeah, that's why. So we can do complex GPU programming. Sounds like a headache setting up, but I hope it's worth it. Definitely worth it. But part of my thing is as well is I want people to copy this idea. Like I don't want to be the person making a compiler and that's sort of like everyone using I have to maintain. It would be awesome if we just had this because why would you want a domain specific language for GPUs? It's kind of dumb and annoying. Like it's much better when you just have one language that just runs across everything really. Even if you have to write separate code sometimes, and this one is optimized for GPUs and optimized for CPUs. The same language, same semantics. There's no messing around, right? I'm trying to hack around this using the fact that GLSL is kind of like C++. There's GNM, yeah. Yes. Yeah, so if you use HLSL, I think tons of game studios do this. HLSL, C++, they can include basically the same stuff, but again, the semantics aren't the same. So you will get differences. But it's the best you can sort of do. You can share structures mostly and share functions, but it's still not it's different semantics. But yeah. So there's that one. So overall, performance will become more stable, which is good. But okay, so there's even more crazy optimizations we can do. Let's do some more low-level stuff. Yeah, HCC should be much more popular than it is. Yeah, it's the only reason why it's probably not so popular is because there's no big games or companies supporting it, basically. But yeah, the idea of HCC should be more popular, right? We should be having C compilers, or whatever language people want to program in, should just compile to GPU with limitations. And we should be progressively forcing GPU vendors to be giving us more power, more ability to take, have pointers work nicer, all sorts of things. Putting pressure there. Because the GPU is the GPU is a very powerful and great device to be able to program for, but to program for it, the tooling is absolutely horrible. And the Vulkan and DirectX 12, it's all just a load of crap, basically, in the way of actually doing some good stuff. Yeah, so I think the Rust crew already do this. These guys called Embark, the Embark Studios guys. They already have their own SpearV backend for shader focused IR target. Okay, just more layers of stuff. They have a Rust SpearV compiler, Rust GPU, blah blah blah. They already do this. I don't know how good it is, but they've probably got stuff that works. I don't know how much they've just gone and copied HLSL and just made that. We've gone all in on binderless. We've targeted more of like the future of GPUs in a way, although we could have really put pointers in. But I wanted to not go that far in the future. But yeah, I don't know. These guys this is already probably something that's usable for most people, especially indies who are just getting into things. But yeah, that just probably compiles out. I don't know how good the project is, to be fair. Meanwhile, on my Mac Studio, I don't know that would work. Maybe. I'd have to make a metal output, which shouldn't be too difficult. But also, we've already got a metal and DirectX. I can transpile. I've made my shaders compatible to be transpiled into metal and HLSL, but I've never tested it. So I've got that in the compiler, but yeah. I use SpearV Cross in the back end. I did it that way just to get something there. An LLVM backend probably be its industrial strength solution. You don't really need LLVM though, because the thing is, if you just compile into SpearV, SpearV is just the same level as LLVM IR. So you basically just compile to that, and the optimizations get applied to the SpearV IR. And you know, drivers will take your SpearV IR, turn it to LLVM IR, then run it through their sort of lower level compiler. Yeah, it's all a crap basically, all these layers. But yeah, I'm just hoping this thing could have existed a long time ago, but no one was doing it, so I just did it, basically. And it's proved pretty well actually so far. We've got it's just proved really nice to sort of just share code mainly, and program in the same language. Right, so should we do some more crazy low-level optimizations, right? So, let's see how many VGPRs we're using. What's a VGPR, you might ask? So in AMD terms, you've got SGPRs and VGPRs. So these are general purpose registers. Scalar, general purpose register, Vive, vector, general purpose register. So what you have, right, is when you're launching in your 32 threads or 64 threads, depending on your hardware, you have stuff which is, you have registers which are shared across all threads, right? So if the information is going to be the same across all threads, that's what an SGPR is for. And a VGPR is for data that's different in every thread. So it's basically like a 32-bit float or integer which goes into a register. Sometimes they have 64 size registers, but yeah, so there's nothing vectorized or anything. It's just scalar, really. So what you have is I don't know if they have 64 registers actually. I think they just allocate 232 registers. I think that's the way to do it. I'm not sure. So this, right, is an SGPR. Can you see this? This comes from the system values. So this is the dispatch group X, right? Dispatch group index X. This is the same across every thread, right? But what is something that is different across every thread? So when you start to do, see, I fish out this, where is it? Wait, no, so sorry. Your dispatch group index, this one is shared. But when we use the dispatch local index, this one is different on every thread. So any information, so this will be in a VGPR, and anything that uses this, it will be in a VGPR as well. Now, obviously, variables have like lifetime. Dev, we're gonna grab some food, catch up next time. Sweet, thank you for the raid, sir. Appreciate it, and see you soon. So obviously you have lifetimes of variables. When the lifetime ends with that variable, they just reallocate that VGPR to another one. So the idea is, why are we talking about VGPRs? So basically, let's just dump this out. We can use these like Mesa things to sort of like get some GPU stats. So what we can discover is that there's a, here we go. Right, so we've got 38 VGPRs that we need for our shader. So per compute unit on AMD, on RDNA, we've got RDNA too. There is 1,024 VGPRs. So, did it hit lifetime? Um, so there's 1,024 VGPRs. So you might be thinking that's plenty, right? You have tons of room if you only got 38. Well, if you're running a compute shader on a compute unit, it can be like, oh, you're doing a memory fetch, or a memory or whatever, something like memory load, and this takes time. So what it's going to do is it's going to have other shaders that it is running right now, and it's going to just switch to one of those that is ready, and then run some more code. So if you have multiple shaders that run on the same compute unit, basically it fixed allocates VGPRs for all those shaders. So basically, the lower this number, the better. And so 38 is not really a good number. What is a good number is 32, because then it's directly divisible by 1024. And yeah, so it's probably just better if we lower it to 32. And I think I've got a way where I can lower it to 32 pretty easily. And that could give us performance increases, because we could possibly be fitting more compute shaders in a compute unit, and they can switch out to the others and simply run more code while a memory fetch is happening. So that would be pretty cool if we could see if that all. So we've already reduced this number from like 60 odd down to this, and it showed massive differences in some cases. So let's see if we can get it lower to the next block, because right now it's allocating 40 VGPRs because it allocates them in 8 blocks. Now another thing to take note is on the old GCN hardware, AMD's GCN hardware, they only had 256 VGPRs per compute unit, which is obviously 4 times less, which means, 32 is directly divisible by 256, and that number is even more, like if you've got 64, that's 4. That's 4 compute shaders they could potentially switch between, which is not good. If you have 32, then you've got 8. So this reducing it to 32 might literally just help for older hardware, but we're gonna try and reduce this down, I think. Yeah, let's try that one. Is VGRs dependent on the shader, or is it code calling the shader? It's all inside the shader. So the shader inlines everything in the shader. All function calls get inlined, and then it just works out what's the maximum number of VGPR. Like, it goes over and does all the compiler optimizations on all the code, and can figure out variable lifetimes and know what registers go onto what variables, or what variables go to which registers, and then it takes the maximum allocated number of VGPRs and then uses that one. So I've got a lovely array here of VGPRs, basically. This is a distance operand stack. Our UI renderer is basically like a distance, it's a signed distance field virtual machine in a way, where it's got like a stack-based storage for distances. So this number is 16, which means that's 16 VGPRs. Oh, it's 8, damn it. I thought it was 16. No. Alright, so I might not be able to reduce it then. But should we just have a bit of a play? If I bring this number down to 4, does it reduce it down? I really thought I had something there. Oh my days, that made it faster. So that took it down to 0.36. So it made it by 14 microseconds faster. Right, so that took it down. Yes, that took it down to 34 VGPRs. So literally reducing VGPRs has helped. So should we? I don't know how much I can reduce this down, to be honest. If I reduce it by 2 more, I don't know if that's going to be possible to compile. We'll see how many times it runs. Yeah, we're going to cert. So we overflow the distance stack. Right, I'm going to put it back to 8, because 8's a really good flexible number to actually make some good UI with. But that's something to take note on. Yeah, it's kind of like that. That's a good way of saying it. Cranston. Yes, Cranston. That's a good way of saying it, Cranston. Yeah. Right. So um how else can we reduce VGPRs? Um, damn it. I thought I was onto something. Um, let's just double check and make sure things aren't being long lived when they don't need to be. Right, so tile core just gets short-lived there. Right, U chord lives all the way to the end. Because it kind of has to. That's 2 VGPRs. Can you recalculate it? No, but it probably gets optimized, doesn't it? Yeah, probably get. Yeah, it probably get optimized if it could be, or maybe not. Yeah, but that's too much work, I think, to go again. Plus, you got to keep these around anyway. Too much effort. Right, next one. Chord is obviously dependent on that one. Tile index. It's kind of short-lived. Start index plus that. Right, so that's a VGPR. No, it isn't. A shared SGPR. It's a tile. That's fine. Yeah. Yeah, so it's probably all inside this for loop here. Yeah. So I think uh, have you done micro optimization based on output SPIV? Any tips you can share? I find it very verbose and use NVIDIA's old CGC instead, but I don't know how transferable it is on newer hardware. So I guess you could do. Ooh. Interesting. What is CGC? Is it NVIDIA's? Oh, I didn't realize they give you access to the instructions. Is this on NVIDIA? They give you access to some form of instructions. That's cool. Right. I guess it gives you access to their sort of like higher level instructions. Maybe not. Yeah. I guess that's cool. I never knew they did this. Yeah. So AMD, you can do this, and you can do it quite easily and get access to it. Using the Mesa driver system again. But it's, you know, if I have tons of shaders, it's going to be an absolute job to find the right one. And also, I tried using their shader compiler, and it's absolute dog crap. Like, it crashed. It also didn't have a way to disable the SPIV validation thing for scalar block alignment, which it should have done, and it's just honest, just terrible experience. But yeah, I've not really done too much of this because I've not really needed to yet. I'm just mainly doing the sort of like uh, doing the sort of reverse engineered approach first. But yeah, The nice thing is it works regardless of your actual hardware. I'm on Intel. Oh. Yeah, that's good. That's good actually. Yeah, offline compiler, fantastic. Fantastic. Um, so I guess I just want to double check and make sure that this one is in a. So every thread should be going over the same. So I just want to double check and make sure this is inside like a. So if we say like wave, damn it, wave active min U32. I'm just gonna kind of try and ensure. So this will basically min the command index across every single thread that's running in lockstep. And they should be running the same one. So I'm just double checking to make sure it's not getting. Because if it does, it means it will make this. Like if this is not an SGPR. Right, tile index is dispatch index X, Y. Oh, wrong one. That's the wrong shader. Don't mind me. Yeah, tile coordinate, which should be SGPR, right? Because it's read from a buffer based on, yes, it should be SGPRs. So I just want to double check when we pull out this command, is it really thinking it's all in SGPR? So we'll just see if we reduce the number. So we were on like 38, weren't we? Right, so let's just double check the numbers. We should be seeing 38. Right, we're still seeing 38. No, I'll just show you. We'll do this. I'll delete the line. Save it. Run it again. There's 38 there. Alright, so that's good. So let's put is we're in SGPRs then. There. Cool. Yeah, I don't know what else I can do to optimize this shader anymore for VGPRs actually. I thought this distance stack could have been the answer, but then we actually had quite a small number anyway. I thought I did 16, but it was 8. But that's cool. No worries. So we've got that as good as we can get it. What else did I want to do? So let's remind myself quickly. So we've done the dispatch indirect, so we're able to reduce the amount, only draw parts of the screen that we actually want. We've increased the tile size, which has made it so cache efficiency, or so it's using the same, it's sharing the same sort of cache values in the same compute unit. And we've seen that because the shader is now running at it's running at a very similar like speed basically, isn't it? Like the speed is not jumping up randomly by tons of microseconds, right? It's only jumping up by it's not going up by tens of microseconds, it's going up by microseconds instead, right? So that's good. It's a lot less variable, right? So we've ensured that. What other optimizations can we do? All right. Um, A bit over the top. Were you talking about making the shader switch statements faster last stream? You probably thought about this, but how about making your compiler sort the cases and doing a binary search? This removes the ability of the user to tell the compiler which case. Right. Yeah, so the problem is, I'm not sure what you mean by sort the case statements. Yeah, maybe these could be moved the other way around. But yeah, we can't sort the draw list. The reason why we can't sort the draw list or the draw commands is because they're already sorted. They have to be sorted front to back. Because we do front to back alpha blending, so we can early out when a pixel is fully opaque. So we early out as soon as we hit opaque pixel and don't do any more draw commands, basically. That's what we do. Make compiler sort the case, but doing a binary search. This removes the ability of the user to tell the compiler. Oh, custom attributes, weights even. Right. Yeah, I don't know. Yeah, I don't know really. I'm not sure if I have full control over that. I can obviously reorder them, and maybe the fact that they're reordered in the SPIV does help, but I'm not sure. It entirely depends what the lower level compiler actually does when it takes its GPU stuff. No, it makes a switch. There's a switch op in SPIV. So I just use this one. So I don't know what that gets compiled out to. Yeah. You'd have to manually hard code it in, basically. But yeah. Right. Okay. So here's what we're gonna do now: is we're gonna write a new scene. So our current scene, I think, is the best we can take it. But what I want to do is just let's do a real world use case, right? This is not a real world use case. It's more of a demo of all the features we have. So it's been good to sort of optimize on this because it's it's using these sort of it's doing unions of things, and this is for stuff like little fancy graphics that you might want to do. So you pay the price of having this flexibility or using the flexible features. But most of the time we just want to draw boxes, right? Because that's all UI is, mostly just boxes. And it can actually be quite simple. So I want to just draw a bunch of buttons, tons of buttons all over the screen, and let's just see how much better that is. But we could also, yeah, and then we can play around with tile size. We can up it by another 2 times and see how well that is. What else? Yeah, let's just do a real world example, right? So we're just going to make a button and then just buttons everywhere, right? So we can just actually switch between these scenes as well. So what I want to do is do an else here, or do an end if actually. So we're right to the top. Oh, we didn't see Mickey Mouse in action. Should we see Mickey Mouse in action? We got to see Mickey Mouse in action at least once a stream, right? Please don't crash. There it is. Oh, it's not. Where's Mickey? I thought it was faster than this. It scales now, doesn't it? It uses the transform, so the SDF gets mucked up. Anyway, that's meant to be faster. Ooh. Anyway, we're seeing Mickey now. Everyone happy? Okay, so let's let's do another test scene with our super lovely drawing API for the UI system that we've still got to write after this. Oh, that's gonna be so much fun because I really want to take some super simple approach, and I want to see how it turns out. Can't wait. Driver does that though. The fact that it can be performance difference depending on the order cases suggests that driver does somewhat naive. Yeah, I think it does it naive. Because I think they want the user to reorder their switch statements manually, case statements manually, and I think that will be fine. Isn't clipping meant to be improved performance? Not really, because it's a whole custom shape. Look at all this crazy that we're doing. We're doing like 3 different coloring operations. We're doing 3 different shapes that we union together. That's all on that SDF virtual machine thing. And then we test to see if the pixel is inside out based on the distance. So it's actually you're doing that per draw command. So it does decrease performance. So, well, yeah, that was quite expensive, wasn't it? That's cool. But that's the price you pay for the flexibility. So what do I want to do? I want to make a button. So the way you just make a button is just say draw shape ABB. We're just going to draw. So this is in local space. So local space is going to be 0, 0. And then what we want to do is also have a size. So the size in local space might be, let's do that. And then we'll do a UI draw finish and we'll position it on the screen. So let's just put it, I don't know, 200 by 300 in. Something like that. So we obviously need to color it. It's just going to show up white right now. So let's do a super lovely border. If 16 pixels, is that a lot? It's kind of a lot, isn't it? Let's do 4 pixels. That's really what you're going to do for UI, right? So let's try that out. And it didn't work because I didn't enable this one. Ta-da! Right, here's the new test scene. There's our box. Isn't she beautiful? So we haven't got any rounded corners here. So should we do a rounded op on it? Expanded. Yeah. An expanded round radius. This is just in general what we'll be doing is something like this. And let's say it's got a radius of, I don't know, it's 50 too much. Right, that's made it bigger. So if you make it 50 less. Yeah. Right, so it's a super rounded thing. There you go. So what we might do is actually pump that into the local variable. Genius name, as you can tell. So you want to kind of like, you know, min it or min this with like the width and height or something like that. Or whatever it is, yeah. We need an actual UI rendering system or whatever. So there you go. So 50, like this is a bit big for a button, isn't it, really? So should we make this smaller then? So what we're going to be doing is saying, okay, well, let's say 50 and then 25. So make this 25. I don't know how it behaves when it goes negative. Do we want to try? It's probably a good thing to try out, isn't it? If the stream crashes, let's blame Cranston. Right. It does that. It makes a little eye, apparently. It still renders. Is that because the round radius? Right, it doesn't render anything. But then the rounded operation. Yes, the distance ends up being negative or whatever, so it doesn't draw them. This round operation causes it because it just extends it, I think. No. Sorry. That's completely wrong. That was wrong interpretation. No, that's a good interpretation. Right, it just does nothing. Okay. So the round seems to... Yeah, so over 50. I guess it is because the round up. Can't you do box size, take away border radius in the shader instead of subtracting the border radius manually every time? So, what you're saying is like make it part of this here. Just put the radius here and avoid doing a round operation as well, yeah? Is that what you're saying? And just do it in the shader instead. Yeah, because we could do this and this would probably be an optimization. And if we're doing this a lot in the game anyway, it's probably better if we just did this. But it depends. So the bounding box automatically has a round radius. Or a way to round the corners with the radius. Is that what you're saying, not so red? And just do it in the shader. Okay, so let's put that 25. So is this a button? Sweet, that's about button size, isn't it? Can really be a bit smaller though. Is this a button? Right, then we're gonna put some text in it. Maybe it should be a little bit wider. Let's do 75. And then I want to put some text on it. So the beauty is you can actually do... I meant always subtract the radius from the size before you draw the... Yeah, the problem is you don't know. When you do this, you don't know. You've already placed this into the GPU buffer and you don't know what the shape was before, and the shape... Yeah, because the problem is this one, like in the shader, you just take the distance. You're looking at the distance on the top of the stack and you're just modifying the distance. Yeah, so unfortunately you can't do it that way. But if I was to make it part of the actual ABB, it would be probably a better thing. So now the text, I think we want to do another command for that. So we'll put that in the same center position, I think. And we're just going to put the word, put like a test word in it. So we'll do glyph. No, you do ABB, because you can actually do different shapes and then color it differently. Have we got to do a draw command per glyph? Probably, actually. Glyph. Right, how do we get the glyph ID again? UI. From ASCII, right, T. Let's just make it white, right? I'm very creative individual, as you can tell. So the offset of this one is going to be negative 65 because it's going to be about 10 pixels in height, I think. Oh, sorry, negative 65. on the X in local space of the draw command, then it's going to be do we really do 1010? It might be 20. 20 actually, we'll do 20 pixels. Just blow up twice the size. So we'll do the same thing again. So this would be 20 up, 20 up, 20 up. Test. We kind of want to make it a little bit longer, I guess. But let's just try this now and see how well that works. Right. So we're not seeing anything. It's front to back. So if it's front to back order, the text needs to be drawn first. That's why. And we are kind of doing, we should really remove the performance. We're going to be blasting over full screen anyway. So I don't think we need this. Disable that. So this will, yes, this only runs it on the tiles that need it. Right, so that seems to be a bit buggered up. Yeah, so that's proper quick now. So it's only rendering the tiles that it needs, right? So we visualize that for those who didn't see it before. You know, it only renders these tiles here. Probably the distance on distance stack is getting baked into the subject. Yep. Something like that. So why doesn't this one? Oh, this is a half size. That's why it's still been drawn over each other. So that means we need to increase this by another 20. There you go. Nope. Don't mind me if getting that incredibly wrong. Right, so let's work with just one for now. Right, so it's only done a little thing there. Not good, is it? You still think the values are still wrong? Okay. Oh yeah, this should be 20 up, isn't it? Yeah, that's true. That's better, isn't it? Yep. So why is this one only rendering... ...2015? Oh, no, it's... Yeah, so difference of 40, good. That's 40 as well, isn't it? Yes, it's 40, isn't it? Then why is that only 20? Only 20, isn't it? Yes, difference of 40. Fantastic. Right. So for some reason this is not being rendered right. I thought I did the glyph thing. I thought I did the glyph in the other test code, where I disable this test code and run this one. This is a glyph here being rendered. So we have an example of it actually working. But for some reason we didn't get it right. So let's make it 100 by 100. And let's see if that helps. Right, so we are getting the T becoming visible now. Let's make it a J. That's weird. Why is it working for... So let's copy this, let's place it here. Oh, it wasn't a capital J, was it? Or is it a lowercase j? So if I made that a lowercase j, it would decide to work, would it? No. Right, I think it's the negative... It's the negative coordinate. So if I was to say negative 20 on that, would it not like it? I think it's the way it's in the bounding box in the negative space. Yeah. Alright. So the way we calculate in the bounding box is just wrong. In the back-end code, so let's sort that out. Or in the UI render code. So the way the system works is, let's get Flop Milton out. So basically, right, you have your command and you say, hey, the command starts here, and you can start drawing shapes inside and anywhere. So say if we put a shape here, that's negative space, or negative on the left at least, and this would be in positive space over here. You put two shapes there, say this is a box or whatever, it's that shape, this is a circle, whatever, okay? Then what it's going to do is put a bounding box around all of it, right? And the way it does it is this is origin 0, 0, so just basically, it should be at least, absolute in this, so it puts into absolute space, and then it takes the max between all of that. So something fishy is going on there where it's not, so it just puts like, it doesn't put a bounding box around it really, it kind of takes the maximum size, so there will be a bit of, it takes the maximum size and puts a bounding box around it. It does it so the shader code can be more simple. At least that was the idea. So we'll do the AABB at least. Let's go to the draw AABB because that's the clip one. We also need to have a clip shape. We'll do clip shapes too. Run the repo on PC. Seems to still be an issue with NVIDIA cards minimizing, maximizing in your code. Yes, that is... Is that with the swap chain stuff? Probably. Oh, or it could be Windows. I forgot what it is. Thoughts on GUI debuggers on Linux? I don't know. I've not really used any IDEs really recently. But I just use GF. I'm not sure if you've seen GF. It's a graphical front end to, it's made by Next. Graphical front end to GDB. So unfortunately you can't download yourself a GF, but that's another topic. Basically, you still have to know your GDB stuff, but it gives you like stack traces here, and you can click and do stuff in here, which is kind of cool. It's pretty good. It's better than most things, and it's quite lightweight. You can sort of like, well, it's better than using the built-in interface of GDB, right? You can download it and compile it on your machine super easy, and yeah, that's what we use. It's pretty decent. You can also support him and get some more features like a little profiling thing and such. Yeah, so check out that. Yeah, that's what we use. It does the job. We also, I don't know if you know about programmatic breakpoints. So you can say like if something, and then we have this thing called core breakpoint. You can do this in Windows and Linux. It's really great. So on Linux, it's built-in debug trap. On Windows, you do debug break. Now, the reason why I use these underscore versions, right, is because it actually puts an instruction in there, meaning that when you break inside the debugger, you're not inside a call stack of some standard library function. No, you're right at the where the instruction is in the function where it actually is. So you can do programmatic breakpoints. So I find that when I want to put a breakpoint somewhere, rather than having to go to the bit in the debugger, what I do, since I don't have it in my actual code, what I do is I just put in a core breakpoint, and that is the breakpoint there, and I just hop in the debugger and it'll just go there, right? And you can put if statements around it, and it's just easy to work with. So that's what I do. I find it easier to do that. Yeah, term debug, I don't know. I've tried some Vim stuff in the past, but it's not been good. I'm not sure what they're like nowadays. I've not tried it recently. So, right, what is this doing? Right, so it does your sort of like half dimensions of the box. So it gets the half dimensions of the box. So it's the local space of, to do shape to command matrix, bring it into the command space. Good. So you're multiplying. So you get your half dimensions, all the different corners. There's this guy. Set it back to 0. And you take the corner, multiply it to take it into command space. Absolute. You take the maximum of those. That's what you want, isn't it? See, something's not good about that. So yeah, we put the core breakpoint in. Let's figure out why. So we should be expecting is a part of core Vim, so it should be okay after it's had some short days. Oh, okay. No, but I want it to be max of ABS. Because the whole point is if it's negative, I want it to be positive again. Like, so here's where our draw command is. We've drawn 2 boxes. What I want to do is find the bounding box around it. And the way we do it is a bit hacky. Say if this box was here, and here's the local space, where local space from the actual command. The way we do the box, the bounding box, is we actually do something like this. Crap. Oh no. Has it got to make it square then? Oh, maybe this is not a good idea. Because the problem is the way I want it to work is that the box why is it we need it? Yeah, so the command itself, all we need to know, we don't need to know, all we need to know is a half size about the box. So when we transform our pixel into command space, we can do a simple check to see if it's in or outside the command just with the half size. There's no subtraction we need or anything, or any extra subtraction. So what it does is it takes yeah, so it'll double it out like that. So it'll be something like that. So what it does is it takes that maximum sort of size. And so if you have like a point, it will say, well, it's possibly inside, it will say, well, your point is inside this command here because that's just the way the bounding box has been made. It's, yeah. Make sure that's fine. So we want to essentially say, like, get this corner, take the maximum of it, or sorry, make that absolute so it puts it over here, and then it'll take the max of that and the current half size we have, right? So that's the reason. Yes, the reason why we do it is so when we do this tile code here, the binning code. When we do the binning code, we essentially just want to be able to store, let's just like less memory basically. Just store the half dimensions only. And then we can translate our screen pixel into draw command space. And then just use the half dimensions, but maybe it's good just to have a full bounding box. Yeah, it's probably better. Maybe. Why else do we use it again? There's another reason. Yes, it's so when we translate the texture coordinates as well. Yeah, so we don't have to offset. Yeah, so yeah. So make sure that this is in the center basically. So we can just do a divide and get a UV. Whereas if we had a bounding box, we'd have to do some extra maths. So it's just to reduce the amount of maths basically, but we end up using more space. So maybe that ends up running more things. So you have to make sure it's basically like, if you've got something on the far left here, you should have something on the far right over here. That's what we'll keep an eye out on. Sounds like it should work. If people make sure to center their shapes around the origin, the command shouldn't lose too much performance. Yeah, that's the idea. It's a little bit of extra headroom though, not gonna lie, to think about it. Found started talking to me, so Mistiv. Oh. Oh. Yeah, I think it's to do with the swap chain basically. Or it's Windows. Or it's the Windows Win32 stuff we've got. Something like that. But it's fine, just, don't minimize the game, Fine. Who minimizes Windows anyway? It's all about just switching, So... yeah, we want to debug run this to see what happens. Okay. So what we've done is we've got this render frame, and we've passed in negative 65 plus 100. Right. So we should be seeing 100 and negative 165, so it should be 165 on the X or something. So this should be... right, so that's saying 100, 100. So we should be offsetting it by center position. So... is that right? No, because that should be encoded in the shape to command matrix anyway. So there's an issue there. So you've got the negative 65 here, right? So, okay, let's go into here. So you encode all those lovelies in there, so you have like, 100 and negative 100, that sort of thing. So you got your corner. It doesn't seem right. Why is that? Because the translation is negative 65. Oh, it's a V2, not a P2. That's why. That's a point. We're translating a point, not a vector. That's why. So I wasn't doing the translation. Cool. So that should fixed it. Let's get rid of the breakpoint. No. Let's run that again. So we've got 165 now, so it's increased the bounding box. We've just moved it to the left, isn't it? Yes, that sounds about right, doesn't it? Right, so if we make this positive, should we see if we can fix it by making it positive 65 and see what happens? Oh. Right, so I shaved off a bit of the T as well. Dun dun dun. Right, so there's the T. So by offsetting it, it's... So we've offset it by 65. I don't know, something's fishy. I think this feels a bit wrong. So you've offset by 65, and if this is like half size, so really it's like should be 200. So by saying 165 as a half size, you're saying it's like basically 300 odd in size. So if you've offset it by 65 to the left, it would be right, isn't it? It's about 300 in size. But how much has disappeared? Shave that T. You know what? I need some more T. Oh, so it's expanded it by... It's just expanded... It stretched the T out, hasn't it? Welcome, Bam Bukia. How you doing? Welcome, welcome. So it's kind of stretched it. That's what it's done. So is something wrong in this code? Why? Why? What have you done? So we've got the command, we've got the coordinate in command space. Oh, right, okay. It's the coordinate command space. Yes, I shouldn't be modifying it by this anyway. Right, so let's just double check. So if I've moved it to the left, what would it have done? So you should be plastering a T over the whole box. I've moved the shape, meaning that there's... Yeah. So if I've moved the shape, it's sort of just made more room, and it would be plastering the T over the whole thing. And the box would have been like if I moved it, it would only be showing like that much of the box. Something like that. That's the reason why. Okay, so I was already just moving the wrong... Right. No worries. So we want to be starting off on about negative 65. Right. We've got this. I need to get myself another T, you know. So let's take 65 away. Then we want to take 45 away. Wait, no, wait. Wait. Yeah, take 20 away. Then we want to increase by 20. and then increase by 60. Yes, so that gives us spacing of oh shoot, why are these? So half sizes of 10, 10, 10, 10. Good. And we've got spacing of 20 per glyph. Fantastic. And voila. So there she is. Looking terrible, mind you. Why they're looking so bad, I don't know. Why are they looking so bad? Is it because like they're pixel aligned? How are they sampling? Clamp nearest sampler. We got a linear sampler in there. Right, so clamp in nearest. I don't see that being an issue. So we've got them about, they're twice the size of their sort of like, you know, if I were to bring their size down to 5, right, that's the half size, so make them 10 in size. How does that look? That should be their native size, 8 by 8 pixels or whatever it is. This proper diddy is definitely placeholder text, right? So we'll look at that. Yeah, there seems to be like, I don't know, something really... 0 to 1 inclusive, I think, is the answer to our problems. We got a 0 to 1 inclusive thing. Something like that. Our UV size is probably a bit too big, I think. Yeah, it's darkness, isn't it? We should sort that out. Definitely. Glyph UV bounds. I think we need to be doing divide by 1 divided by 16. Is that enough? Or is it 1 divided by... What do you want to do? Because does that give me 16? It does, it gives me 16 things, so maybe it's fine. Yeah, the villain dev is coming out. Yeah, the UI stuff's going alright. We're trying to do write a new performance test. We're just trying to fill it out with buttons and finding little issues with our temporary text thing. Just trying to fix those really, but yeah, it's not going bad. How you doing? So we're able to get the right glyph, but I think the coordinates are a little bit messed. Or is it the size? It must be that 15. That worked. Okay, so it is what I was thinking then. I think. Oh no, is it still off? No, that's right. Ooh, it's a little bit off still. It's a little bit of shaving. Right, so what's the problem is the fact that we're getting like 0 to 1 in the shader, and we need to make sure that when we're getting yeah, it's basically an off by 1 error because of that. My days. So maybe I thought this was meant to be a half size, mind you, but okay, let's make it even bigger then. Okay. Alright, how's that looking for a button? See that T? It looks like it's being cut off on the right hand side a bit. But then also that could just be the little pre-rastered image we're using, right? Find the T. No, it's not. Obviously, it's perfect. Right, so I think it's the way it's doing the nearest. It's not. Yeah, it's like. Maybe we are not aligning it. No, we're aligning it on the pixel. It's something dodgy. There's something a little bit off of it, basically. I'm not super fussed about getting this perfect, to be honest, because it's just placeholder text anyway. Yeah, there's something else going on. A little bit off. Oh, hey there. Hurricane. Hurukami. Welcome, Raiders. How you guys doing? Thank you for the raid. Appreciate it. How's things going? So let's just make the button a little bit wider. So what do we do for the... So is that like a standard button size? You reckon it's a bit big? Let's make it smaller, yeah? So let's half everything. Let's go back to the 10s. So let's increase this by 10, this by 20, this by 40. Wait, I forgot which one it is now. I think that's buggered it off. It's buggered up. It's 200. So that should be 20 back. So it should be 1. Yep, 180. 220, 240. I think that's right. So that should be in the correct way. Ooh. Whoops. Close though. Yeah, we obviously went 20 each side, so made it 40. Let me take away 10. Let's try that out. There we go, they're all nice and next to each other now. We'll make the button a little bit smaller. So we'll say, you know, reduce it by maybe 20 pixels. Something like that ought to be good enough. Cami is okay. Okay. And then let's shrink its width as well by another 20. Do your button have something like safe zone? So we're not really, this is just purely rendering right now. We're just doing rendering tests. So what we're going to do is we're going to spam the screen with buttons now and see how good our shader is, how fast is it. So we've got this nice button here. It's got a draw command to the background and a draw command to each glyph. And we're just going to test to see how optimized our shader is, because we've just spent a while optimizing it. See, it is off by a pixel. Damn this thing. It's off by a pixel. What would that be then? We did reduce it by 1. Should we have a bit of a play just to fix it? Because I think we can if we just spend a little bit of time. Yeah, so we've spent ages optimizing our shader. We've got like a tile-based renderer, tile binning. So if we switch the tile mode on, you'll be able to see that it only renders pixels it needs. So we'll enable this one here, which enables the visualization of the tiles, and there you go. So here's these tiles which render the UI, basically. It's just all using compute shaders. We should switch a light on. Yeah, zoom's aliasing. This is the worst feature. I can't believe KDE, when you zoom in using their built-in zoom, it doesn't do a nearest sample as a linear sample, and it's useless. Like, why do I want a blurry screen when you zoom in? It's horrible. Like, this is all lovely and aliased, but the zoom feature's not showing it. Or anti-alias, sorry. Yeah, but anyway, things. So I think we should be able to glyph here it is. Right, so we did that 1 divided by 15 and it fixed it. But it meant it was kind of like missing a pixel right on the end. Yeah, I know, right? Silly. I should file a bug with them, really. You know, I should file a bug and just say, hey, we need this as another KDE option, you know? Because there's not enough options in KDE. Right, so it's clear there's two things there and it should go out like that, right? So we'll look at that one. That does look like it's come off as well. So it's clamped on the edge by about a pixel because we've doubled, yes, it's a pixel off. So I reduced it by a pixel, so hey. Of course the size is going to be too small. So if I make it bigger, it looks stretched and horrible. Right, so clearly the box, so it looks stretched and horrible. The 10 by 10 font. Oh, why am I doing divide by 16? Because it's 16 across. Yeah. Alright, what's the answer? Let's go to the coordinate, the glyph. Alright, let's think about this thingy. So, the bottom left is probably being calculated fine. Okay, how does it look like it's messing up? Does it look like one of them is fine and the other one is bad? No. The X maybe looks okay, but the Y is wrong. Is that right? Maybe they both look wrong. Yeah, so I think in this case, the Y looks... Like, we could just take a screenshot and really see. So the way we can suss it is just running it. Do a screen grab. And just open that up in Krita. Just count the pixels. So you got this lovely aliasing, look at anti-aliasing, look at that. Isn't she beautiful? Yeah, it could be, I think it is to do something to do with that. Yeah, that does sound familiar. So in terms of pixels, damn this thing. Oh, it's still off. Still cut off here. Or not even. Yeah, so the X is not even either. Yeah, so we know that for sure. Good to know. So that's how it was before, then we fixed it by reducing it down to 15. But it appeared to be off by a pixel, right? So we now try this one. Let's do a nice little screen grab. Yeah, it could be that 0.5 thing. Now if we look at this, that's basically better, but this is now missing. So how many should it be? We've blown up twice as much. Can I get like a grid? Alright, let's just open up and create them. Ta-da! So the pixel for the T at least. It says 10 by 10. What's that? 8 by 7. Yes, it's quite hard to tell actually. You can put a 10 by 10 grid down. Um... Not the right type of settings, I think. Oh, it could be right next to the option. No. Um... Settings, Dockers. Grids and gads. Right, it's 20 spacing, so we did 10. Voila. There we go. Oh, you're talking about the sampling. Yeah, you got a sample from the middle, isn't it? Basically. Because otherwise it will... We are using a point sampler though. But yeah, it needs to be rounded. Upper left of the screen. We might need to do something actually. Yeah. It is upper left in Vulkan. Bottom left in OpenGL. Variable represents the location in window space, yep. Coordinate origin. Right. X and Y will be shifted by half a pixel, so the center of each pixel. Puts it. So the center of each pixel is an integer value. I'm not sure what they mean by that, because it'd be a float, surely. But yeah, it could be that as well. But I think we flipped the texture or something to deal with that problem. Yeah, it's similar thing though. Yeah, that is for the frag chord. Correct. Right, so here's our box. So what we should be seeing is like 3 pixels. Damn this thing. 2 pixels to the left. 2 pixels to the right. So it should be 4 pixels because we've doubled the size, basically. But yeah, I don't know what that is. Actually thinking about it. um, oh no. 2 pixels to the left, so it's 4 pixels. You should be seeing something like this. So we should be seeing is that 20? So it should be ending there. 1, 2, 1, 2. Sweet, so that should be the width. Where's the bugger gone? Where's my selected? Oh, it's here and it. There's too many of these things. Width 20 pixels, perfect. So, okay. So that's the width that we should be getting for that individual thing. And obviously it goes 20 up as well, but anyway. Yeah, I'm 1 pixel off for some reason, so we've got to work that one out. Right. I'm just going to take a quick pause because I'm getting low on fluid. Get a nice new tea, and so I'll be back in a couple of minutes, and then we'll sort out this issue here. Right. So enjoy the tunes while I'm gone. Does it keeps going between these two? Right, there we go. I'll be right back. Alright, welcome back everyone. How we doing? Okay, so we're trying to just quickly figure out where our texture coordinate is a little bit off here. Yeah, because we're just writing a test, so we can just spam a whole ton of buttons over the screen as a performance test on how good our shader actually is in the probably realistic example. Well, it's not really a realistic example, maybe because there's a bunch of text everywhere, but maybe we can minimize. I guess this is a stress test, and we just want to see how good it is, right? That's I guess is a way of saying it. And maybe we can fill like do half a screen of buttons and a full screen of buttons. But yeah, so we're just trying to figure out why this text is not perfectly rendered. So the problem is just look at the numbers we're passing in. We don't have linear filter available. The output of that might give us info if your sampling centers are pixel centers or pixel borders. It's on a pixel border. It's definitely pixel border. Yeah, it's definitely pixel border. So if I offset the so should I offset it by a texel, half a texel, which would just be so it's 256 pixels across, right? So it's 1 divided by 256, then half of that. I'm not sure, should I be offsetting it by this or not? And then the size. Would it have to be take away times 2 of that? Right, that fixed it. Sweet. Look at me go. If I actually take a screenshot of that, we'll be able to see it. Right, so there's the fix, right? There's the old one. There's the fixed one. Can you see how this thing here is 2 pixels and actually stretches out a little bit more? Yeah, it'd be better that way, isn't it? It'd be more readable, wouldn't it? Yeah. I did it post rather than pre. No, the problem is I'm not working in pixels though. The problem is I'm working in glyph indices. So yeah, it would be 160. Well, yeah, it'd be 1/32 or whatever. I don't know. Right. So I'll do something readable. In UV space. There we go. Cool. So now we've made the text look beautiful. The next thing to do is spam as many buttons over the screen as possible and see how good this thing actually is. So here's our button, right? So how do we do it? We just stick it in a for loop. So if you wanted readability, you could probably define those variables as, yeah, that's true actually. That would be even better. Constant folding. 1 divided by oh yeah. So we're going over y 0 to about, I don't know how many buttons do I want to do. I could have done it. Yeah, this is a classic for loop. F32 y equals 0. Y less than the temporary display height. Y plus equal the size of a button, which is size of a button is about 30 in height. X and X width. See, I guess this isn't a realistic example either because we're doing the same, you know, only using bounding boxes and stuff like that, but I don't know. I think it's a good stress test though. So the X coordinate is about, so it's 55 across, that's the half size, so it's 110, right? So that's tons of buttons there. And now we want to So if, yeah, we'll have them, yeah, we'll just do that. So we're putting the X and Y in here. And this be X take 10. This will be X take 30. This just be X plus 10. This be X plus 30. This will just be Y, 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 and Y, like I always ask. Cool. So that right there is hopefully a full screen worth of buttons. Please don't destroy my GPU. Okay, we got a crash. That is because we right, we did too many words. So our words array is too big for the UI. So where's the draw words array size stuff? So the draw words are too big. We need to do a clipping shape actually. We should do a few clipping shapes. We might do a clipping shape per row or something, or per couple of rows, I don't know, we'll see. Because we are going to be using clipping. So when we initialize, so let's do 32K then. So 16384 add. Right, it's still not enough. $64K. Oh yeah, isn't she beautiful? So there's a full screen worth of buttons, and the tile binning is taking 1.3 ms to bin all of those guys. Um, yeah, so we're getting a lot of, because we're doing all the little. So this is about 5 draw commands per button. It's part of the issue. 5 draw commands per button. But the UI rendering is quite decent because it's probably not going over too many per tile. There's not a lot of overlap at the moment, but we could drop some more things in. Like we could just fill in, like as an example, right? Yeah. What happens if I add a background in? Let's add a background in, and let's see if it makes how much slower it makes it. So I'm thinking we should increase the tile size by some more to make the binning quicker, because the binning's quite expensive, I think. Right, so I've added a background. It's now increased it to about 0.8. Oh, sorry, from 0.8 to 0.9. So if I put in 2 more of these guys, does that keep putting it? Right, that doesn't change much then. Okay. So I think that was able then to not, without a background, we was able to draw less tiles on the screen, right? That's the idea. So if we run this one, oh, maybe not. Because I thought about the edges, maybe didn't have any tiles, but they do. They're more than 16 pixels, which is fair play. Right, what else? So if we increase the tile size to 32 pixels, it's a lot bigger now. So if the binning is taking about 1.3 ms, which is quite a bit, we're hoping it's probably half that now. Let's see what we get. Right, that made it worse. That increased this one significantly, and the binning didn't get any better for some reason. So the reason why that is probably true. So wait, where's the visualization? Yeah, so let's visualize the tiles. See, they got bigger now. They're 32 pixel tiles. So this would then mean you've got more overlap between. Yeah, there's a few things, right? You've got more overlap between. Let's run this back again. Say 32 pixels will cover like more places where you've got 2 buttons over the same sort of tile. So there's that reason. There's more. And also the other reason is you've probably got yeah. Yeah, you've got more sort of like waves which run over sort of like more draw commands and will last longer or something like that. So it's not ended up being beneficial. But what was weird is why this binning shader wasn't faster. I was expecting the binning shader to be faster, increasing the tile size, but it ended up not being faster, which is weird. Right, so I think we want to try and optimize then is can we make the tile binning shader faster, considering it's got to go over all of those commands. So 16 seems to be the sweet spot, so that's good. I'm really confused on why. Are we just dispatching more than we need? Can we go to binning? That seems sensible. Why would this not be running quicker? Because surely you're running less compute. We can hop in the debugger and see. Well, let's just try it. Let's just print out this, right? And we'll monkey around with that constant, and that should change. So that one is 10. So it's going 10 across. When we up, when we up the tile size to 32. It's because it's 8 by 8, isn't it? You get 5. So you're getting wastage, potentially, on the compute units. On tiles that simply don't need it, I think. Yeah, so because... Yeah, so we've really got to monkey around with this stuff. I can see it now. So the reason is because you're in 8 by 8 tiles. So if they're 32 in size, you have more dangling off the edge, basically. Right. So we'll figure out, is there can we make this faster? Like, what are the bottlenecks with this shader, basically, and what can we do to make it better? Because it is, the more draw commands that you have, the worse it gets. So how many draw commands do we have right now? So it'd be good to get that number, wouldn't it? So let's start with that. The number of draw commands we have. So we can get that number by simply looking at here. So how many draw commands do we have? Yeah, 1920 draw commands. Okay, that's a good number. So nearly 2,000 draw commands being rendered and binned. Didn't see the test button. You sure it's there? What? What do you mean you didn't see the test button? I see what you're saying. Right. Yeah, it's just test it all in your face. Yeah, it's too many. Too many. So make this guy go faster. Yeah. How are we going to make this go faster? That is the question. So we're doing 8 by 8 tiles. Like, so if we made this 8 by 4, it's probably running in wave 32 anyway. I doubt making it 8 by 8 is going to make it better. Frosty Ninja. Thank you for the sub with Prime. Appreciate it, my friend. How you been, sir? How you been? You're going to check out the code as well. If you go join the Discord, link your account, you'll be able to download and have a play with the code on your local machine. And I appreciate your support as well. So that has made basically no difference. Doing 8 by 4. I think it's made some difference. There's like some microseconds there. Maybe not. I don't know if it really did, because it could have been running in wave 32 mode anyway. Let's see, right? It's better getting 35, 36. Yeah, it's just showing more 6s there, whereas everyone was showing more 5s. So it was kind of a bit better if we did, right? Micro optimization. Okay, so that wasn't massive. I can check the number of VGPRs, right? I think it's that one there. It's not, the complication is not much. So like this is, you know, so it should be pretty easy to sort of chuck that in a ton of these in a compute unit, right? So that's not the issue. Why is there a distance stack here? Copy and paste problem. That just gets compiled out anyway. That'll get compiled out. Yeah, so they shouldn't make any difference, right? Good. Cool. So that was just excess stuff in there. So what we've got to try and do is figure out how we can bin per tile quicker. So another way we could do it is we could dispatch. We can write this again but inverted, or the inside out. Do it the other way around. We can say every dispatch does one command, but then it goes over every single tile. Right? So it goes over every single tile instead of a tile going over every single command, right? And if a command goes over every single tile, that means it's only doing the matrix multiply. Oh, no, wait. What is it doing? What is it translating again? What is it doing? Tile center position in screen space. And it translates that. Yes, you still be doing the matrix multiply, but you won't be loading many matrices out on a for loop. Right. So I don't know. I think this one is probably faster, but I don't know until I try it, I think. But then, oh. Is life too short to write shaders? Sure. What do you mean? I built my own little shader compiler as well. So, I don't think so. I'm trying to build STO2, but it fails because of make target not found error. No. Yeah, build systems. Lovely. Build system. Yeah. Should take a look at the docs and see if you can find something. I have no idea how to work it. It is also SDL3 now, isn't there? You're using SDL3. Have you tried that one? So if we convert this the other way, you'll be pulling out, you'll have this matrix. It would still be VGPR. You'll still be doing a matrix multiply. But you'll be pulling out a matrix per thread when it starts. It'll be hanging around, right? And then you'll be going over all of the tiles. And the tiles, see, this one goes over all of the matrices and pulls it out for the lifetime of the shader. And every thread is going over all of the commands and pulling them out. So, right, as opposed to the other way around, the matrix will be hanging around for the lifetime of the shader. And then all you'll be doing, you still be doing matrix multiplies, but you could calculate the coordinate with maths, and that'll be on the inside, right? And then you would be doing your point. Like the only issue is like this at the end, you won't be able to do. So we're doing this. And the only issue will be the insertion, though. The insertion of the What about it? The insertion of the draw command into the tile will have to be... You can use an atomic though. Oh, easy. Yes, let's do it. Let's do it. This will be fun. Right, let's do a version 2. Or a second version. Right, here we go. If 0. Right, let's invert this. We got this. Easy peasy. Right, tile binning the other way around. So this one, we're going over every single draw command. So we'll just do one by, wait, 32. 32 by 1 by 1. Yes. Then, so yeah, so what we're trying to be is about 1.35 ms for a full screen worth of for 2,000 draw commands. So instead we're going to be doing .x will be equal to your command index. Then you fish out your draw command, get all of these lovelies. Bring these so if your command index is greater than draw commands count, wherever that one was. Draw commands count, we end, so that's command index. Right. Awesome stuff there, Cranston, helping out Ransel there. So you'll be pulling out this per thread, it'll be different per thread, that's fine. Now this one, you want to do a for loop over all the screen tiles. Do we have the screen? You have tile dims, right? Number of tiles across the screen, perfect. Which means you can do a 2D loop. Why do you want to do a 2D loop? You probably just better off doing a 1D loop. There's one less. Yeah, I think it might be better. So you want to do like number of tiles. So tiles count equal 20. No. BC tile dims. Tiles dims. Tile dims. Yeah. Dot y x times tile dims y, right? So that's number of tiles. Then we can fold out yeah, so we want a tile index. So we're bringing all this in. Tile index less than tiles count. And running tile index plus equal 1. Fantastic. So that one can go away. This one is your tile. Let's say U-coord. Okay, so we've got to calculate that. So it will be tile index. You're then using like the mod and stuff like that, isn't it? Every time. So maybe it was better for just to do a 2D one, I think. Yeah, screw it. I don't know, maybe. BC tile dims. I'm not sure if it likes just a flat loop or if 2D loops would be better. I have no idea. So then your coordinate would be something like that. XY times by tile size. That gets you your center position in screen space for the tile. So this is the insert position. This is your, which would delete because we'll calculate that with an atomic add instead. This is the start position of where the draw commands go if you were to successfully get in there. Tile index would be, so we need to flatten that out. So the tile index would just be y, x, something like that. And then we're simply storing. Right, so the counter's at the start. The issue is it needs to be zeroed. Memory. And we don't zero this buffer. But we'll think about that in just a second. So what we need to do is an atomic add. And we want to say like, hey, here's your sort of like insert index. And this will go into here. So the first word of the draw commands will actually store a counter, sort of like how many are in there. And then we use the insert index here. So technically it'll be +1. Yep. Store the draw command in there. Don't increment anything anymore. Now, if it is 0, it means this is the first one to be put in, which then means you could do this lovely thing in here now, which will say, hey, this tile has draw commands, which then means it means this tile has draw commands, so you can add it to a list of tiles which have draw commands, and then we can only render those tiles on the screen that actually have draw commands and save some compute. So if you don't have a full screen worth of stuff, we can save some compute. Right. So I think that's a nice inversion. I've got to double check it quickly, but that was pretty cool. I think this is better because it's pulling a matrix out and storing it in the in the VGPRs and just reusing that same matrix, as opposed to going over all of the matrices and pulling them out all the time, and probably throttling the cache. I think it's better because the tiles don't throttle the cache. They just calculate. Their data can be calculated based on the for loop information, right? So I think that's why it's better. It now works. Remove the directory and unzipped it. Oh, weird. Just start it again, basically. Maybe you needed there was some cache in it or something that had gone wrong from a previous build, maybe. Right, so hopefully, let's just double check everything, because Sod's Law I did something wrong. Plus we've got this thing to 0. So firstly, we need to instead change this binning thing to say, hey, 1 across the Y for me, please. And this one will be draw commands count divided by 32 because it's 32 threads per wave. Alright, so hopefully that'll be good. Yeah, so you'll get your command index here now, your draw command, and then we fish out the draw command itself, get its word, get where the words are in the words array for the draw command, fish out the matrix from the word array, fish out the draw command, access line bounding box half dimensions. Get the number of tiles across the whole screen. That'll be shared across an SGPR anyway. Good. Loop over all the Y's. Loop over all the X's. Calculate the tile center position in screen space. So so going over all the tiles basically, right? Get the X, Y, get the center position in pixels, right? This one is then translate using the matrix we've got cached here. Is going to translate it into command space. So you have all these orientations and stuff, but it just puts it into the command space. So if you have an access line bounding box, it'll be access aligned again. And then what we can do, that's your half dims as well. Fantastic. This could kind of be done outside of the loop. Probably the compiler's smart enough to do that, but let's just do it for the compiler. That's interesting as well, so it's one less multiply. This could be pretty good. I just got to figure out to zero this array somehow. Calculate this thing called P. P's magical. Yeah, so this is basically just a bounding box. Like, does a bounding box collide with another bounding box? And one of the bounding boxes around the center is around origin 0, 0. So we just need the half dimensions for it. So we just do that calculation. This means we're inside the bounding box, or the bounding boxes overlap. So it must mean that this draw command, it needs to be added to the array of draw commands for this tile. So we calculate the tile index only then. We calculate the offset into the draw commands array. So there's like 16 draw commands per tile. It's a pre-allocated array. This goes in here. Shoot, I just realized my tile list isn't big enough. Is it? +1. There's some extra stuff we store in this tile. We store an extra 4 words of information in there. So technically no. Yeah, so that would have been, if we had a 4K screen, it would have crashed. Or 4K by 4K. I don't know. Probably doesn't matter. But anyway. Right, I guess that was good to find. So you get the insert index. So at the start, there's going to be a counter, and this has to be zeroed memory. But it's for your... So I think we're going to have to run something which zeros our buffer, not going to lie. It could be quite quick though. But you're zeroing the whole buffer. Based on how many tiles you've got on the screen, it could be fine. insert. We were the first to insert. Um, yeah, we're the first to insert. What is this? So you run all of the tiles isn't gonna bin all of them, is it, in the end? So really we should say if not run all the tiles. Yes, that inserts it, and then we'll do another one. See, the issue is how can we force it to run all of the tiles with this new version? That's another question. We have to add a way to throw them all into the list. Maybe you can just put it in the other shader. Yeah, I'm just going to disable that for now. I don't know, maybe it's not that useful because we can just put a draw command which spans the whole screen anyway. Maybe that's just how we do it. Okay, so this is basically done. The problem is though we have to create another shader now, and this shader is going to be called tile. Like we've just got to zero this array. I don't know if I can figure out a way how to do it. See, unless because the problem is any draw command could hit any tile first. But we could think. So there's no way to know without zeroing an array if I am the first. Well, unless you have thread local memory. Sorry. Sorry, use the local. The shared local memory, right? Or the global shared memory, whatever you want to call it. Because that's shared between all of your groups, isn't it? So if you use that memory, you would need to know a pre-allocated maximum size, and you could allocate a lot of LDS basically. And I don't know if it's it's not a good way of doing it because it's going to be massive. So the other way is having a buffer somewhere and flipping a bit on, but you still got to zero that thing as well. Yeah, I don't know if this is. Yeah, so I think the only other way we can do it is zeroing the memory. Which is a shame. So next to the frame initialize. So I think we'll so in Vulkan, is there a way to sort of like VK Vulkan sort of like zero buffer? Alright, so fill buffer, you can fill it with like a word, can't you? So we could just write a compute shader that does this, but yeah, you can fill it with a U32. So what we might have is a way to zero a buffer. and we can implement that on different platforms. So some platforms might just need a compute shader that runs. But we'll just call it a 0 buffer. I think we'll add that in quick. So it's either that, or we write a quick shader that zeros. Right. So let's quickly just chuck one of those in. But compute shader is just easier. Right. I don't know. Zero buffer basically. So the thing is as well, actually, right, another optimization. We're zeroing a whole buffer. This buffer might be, if you're zeroing a whole buffer and it's 16 times bigger than it needs to be, like you just need to zero the word which stores the counter in it. So maybe the problem is then you'll be fetching a counter in two different memory locations in the next shader, which might be a problem. So maybe it's not a good idea. Right, so let's just do 0 buffer. Let's just whack this guy in. So command assert. What synchronization things are we doing? So it should do the sync rewrite. So GPU sync read write. We want to do a GPU something like that. No? Yeah, so sync read write, then put down a barrier. Put down the barrier, do the buffer 0 thing. We want to get the, music stop. Heck. We want to get the, yeah, good. So we want to get the buffer. We want to make sure it is a buffer. We probably want to make sure it's also a multiple of 4. So probably those two. Buffer size, multiple of 4, please. Of 4 bytes. Cool. So we'll throw that into the buffer 0 thing, and then we'll be passing in buffer ID, no, the buffer itself, into the back end. Pretty good. That's very quiet. Okay. So now we've got to add that new backend implementation for this one. GPU backend. Don't know why these ones are up here and the other ones are down there. That's strange to me. Right. Buffer 0. Why did I say size 0? GPU resource pointer, buffer. Very nice. So all we have to do now is throw this guy in. Probably very similar to the dispatch. We want to perform a, so we'll get to put the timestamp stuff in as well and just see how long it actually takes, which is pretty good. So we're not doing any pipelines, not doing any push constants, we're doing profiling. We want to do a name. So how do we do a name? So it would be kind of good if we used the temporary allocation stuff. So what did I call that? I call that frame allocator, isn't it? Yes. So we get the frame allocator, and we'll do a super lovely core string format. So we can pass in like the frame allocator. Wait. Yeah, frame allocator format. So the format will just be the buffer name, and then we'll say like command buffer 0 and that buffer, yeah. So we'll then pass in the buffer name, which then be in buffer name, debug name. Isn't she lovely? So that will produce a super nice string. And then we can just use so this thing called a name, and that'll just live as long as the frame, and that should be long enough. Is it? Is it long enough? No, because it stays alive for 2 frames. Bum bum bum. You've been screwed. So we might just put in. Well, yes, it's bad. Very bad. So we'll just put in the debug name. It's not good, but or we could hard code something else like command buffer 0. Screw it. That's probably better. Right, so now we need a new. Oh, this VK fill buffer thing. Sweet, got a super lovely fill buffer there now. So we need command buffer, destination buffer, GPU, VK resource backend, so we get the backend structure. Just does some casting from a point. Does like a pointer offset and a cast because it's stored at the end of the buffer or something like that. Get the buffer handle. Buffer offset is 0. The device size, the amount we're copying, that should be size in bytes, right? Size in bytes to fill, use whole size. We could use whole size. And we're filling in 0. But we've made sure it's a multiple of 4 anyway. So we can just do buffer size. And we fill in word as 0. Fantastic. Then there's the thing there. Good. So we should be able to now use this lovely buffer 0. And I guess it's using the more optimized function rather than just using a compute shader, right? So render frame. So before we do the binning, we need to run this thing on this one, where the draw commands actually go, because there's a counter in there, right? Oh, what's happening here? It's X then Y, isn't it? Okay. So now the new shader's in. We just got to see. What is this? Store the number of. Yeah, but we do that with the atomic now, isn't it? Here. Okay, good. Right. So we've just written a new tile binning shader which just inverts the for loop logic. So instead of being every thread every thread being a tile going over every single draw command. Now it's every thread is a draw command going over every single tile. And we're thinking that it should be less, we should be thinking that it's sharing more, it's doing less memory accesses basically, and less thrashing of the cache in the compute unit. So in the compute units. So we're about a full screen worth of buttons is about 1.3 ms, which is quite a lot of time. So hopefully with this new one, it doesn't crash my GPU when we try and run it for the first time. And secondly, it's way faster because we should just be reusing the same information, hopefully. I guess you pass size that just covers the counter. Ooh. I guess you could just pass the size that only just covers the counter. Would have to expose the size parameter though. Maybe not worth it. I'm not sure what you mean by that. Are you talking about like the zeroing when we zero the buffer? Like the fact we have to zero the buffer, is that it? Right, so bear in mind that the GPU could crash right now, but hopefully it doesn't, so fingers crossed. Right, or it could blind us with a white screen. So clearing the buffer is dead quick. The binning is 1.3, is 1 ms now, way less. It was 1.3 at least. But I was hoping for better, to be honest. I was hoping for like at least half off. But we're just getting white on the screen now, so there's something insanely wrong going on. Yeah, that. Going the counter, right? Right. Oh, I see. Yeah, so the count. Okay, so yeah, I see what you're saying. So currently my counters are not at the start of the buffer, but they could all go at the start of the buffer and be next to each other in memory for each tile. But instead we've got arrays of 16 elements, and each array of 16 elements has a counter at the front for that little array. So I could also get rid of the counter entirely, actually. No, but I need it to know when it's the first one. I can add it to this array. Something like that. Yeah, I need it. Um, but I could store it. So instead I could have it null terminated, right? And we never write to the last. No, because then you have to zero it. So. Ah, hello there, Mathrism C. How you doing? Thank you for the raid, appreciate it. How you guys been? How did the stream go? We're currently optimizing some GPU shaders within a UI. I don't know if I got a yeah. Basically, we got a whole screen filled with buttons, like these buttons, a whole screen filled with them, and we just rewritten a shader to try and see if we can optimize. If it's, and I think it's better, but we've just got a white screen right now. But we just getting it up and running again. Yeah, how did stream go? Yeah, if anyone has any questions about what we're working on, feel free to ask, and I'll happily go into more detail. So, hey there, practical NPC. Hey there, math room C. How you doing? How did the stream go? Thank you for the raid. What's the current song? This is Nick Johnson. Nick Johnson is a G. You should listen to all of his music because it's amazing. Stream was good. Was live streaming my cat at the end. But I normally do game dev, okay? Yeah, and here's my cat. Um, but yeah, awesome. What sort of game are you working on? Are you do you like using game engines, or are you like a person who likes making game engines? Um, C, C++? Right, so you've zeroed the whole buffer. Oh my days, I zeroed the whole buffer too late, so that's the problem. So we should zero the buffer before frame initialize, because frame initialize actually sets it to non-zero data. It goes and does some things. It basically pokes in, it sets up this to be 4 and this to be 0s, 1, 1. So, whoopsies, that'll fix it. Please don't break. Ah, damn. It should be syncing on that as well. Read, write, sync, sure. Command buffer 0 is running, it's zeroing the whole buffer. Awesome, you learned OpenGL. Nice. C building game, cool, cool. Yeah, if you're doing 2D, like, you know, there really isn't a whole ton of work rendering side, and that's the biggest part of doing 3D nowadays is rendering. It's a really big pain. Yeah, 2D is a lot more simple. You can cut a lot of corners. Um, yeah, it's a good thing to learn. Um, but yeah, nice. Um, so we're running across. It seems like this is running fine, but when we're doing this, right? So what we're gonna do is we can go to the shader and enable the visualize tiles. So we should be able to see if the tiles are actually being... Okay, so we are getting a full screen worth of tiles with draw commands in them. But the draw commands just seem to be wrong for some reason. Why are they wrong? Like, so you're getting the tile added correctly. You're getting a white screen because it's not... Like, that's the default pixel color. So it's actually maybe interpreting random data, which is really bad because it could have crashed. So you get your tile index, which is y times x plus x. Yeah, dims x, good. Um, so tile list counter plus equal 1. Don't you need to like... Yeah, you reset that, right? You reset that to basically 4. So it can insert into the list. Right, that's the old one. Good, good, good. So inserts the tile. Adds 1 to the dispatch X coordinate so we can do more dispatches. Dispatch X. Dispatch. Yeah, that's fine. So it's more of these. So we'll just pick out the tiles. So that's fine. It's this maybe. So if your tile, like, you know, so this would just be zeroed memory. You're adding one, so this would be what it was before it was added. So you should be able to, yes, you need to go add one to go past where the counter is actually stored. Store the draw command in there. It should be fine. And then when you're sort of like reading the draw commands back in the renderer, you're just reading it out there. Adding one. Yeah, it seems sensible. It seems good to me. There's something fishy is going on, so I think this code is correct because we're seeing the tiles on the screen. So that one's definitely correct when we do the visualizer. So we saw that. So we have got a heat map. We could be displaying the heat map instead. So that's displaying how many command counts are in there. Right, so this heat map is, I think that's correct because we're drawing a bunch of buttons, tons of buttons next to each other, and it's looking like a good heat map to me. So blue is cold, red is warm. So we've got about we've got room for 15 or something like that. So obviously it'd be, when it's like 15, it'll be red. So you get like an in between there. So if the visualizer is correct, it means the draw commands count is being correct. So this thing is being atomically added correctly. You would think that be inserted into the right place. Was putting y in the high, x in the low, I think. That was correct, wasn't it? Let's just double check. Here's the old one. Y in the high, x in the low. Yeah, good amount of raids today, it's good. Never too many raids. Yeah, that's where I don't get raids at all anymore, you know. And today's been like quite good, so it's good to see. Good to see. Mm, why are we just getting a white screen? It seems weird. Like, this shader is the problem because, you know, the other one we haven't changed. So white screen means, so it means that you haven't done a color operation on it. So would have done, yeah, I don't know. Yep. So it's putting the right number of draw commands down. It's definitely doing that. We could do another where we color based on the draw command. Like if your pixel hits the draw command just early out. There could be another one. So we can have a bit of fun with that, I guess. Like, I think we can do that, right? Where we just color it based on the draw command. So you do your draw command here. You know if your pixel hits the draw command if you run the loop once and what? Your distance on the top of the distance stack is inside or something like that. Shoot, what's all this? Did I go too far? Yeah, going too far. Yeah, so you put this thing here, uh, inside here. Inside here. It'll be off by a pixel. So maybe that's not so good. So say like if it's inside the shape, we'll take the command index, we'll times it by this big prime, do something like that, get a nice color, and we'll render that out to the screen. So this one, enable to visualize the commands. It's a pretty good visualizer. Right, so hopefully this doesn't blow up the computer. Right, so I was hoping to get something different. Is it? See, I can't know if it's going to work. Right, so how about this? If we run, let's disable it. Let's re-enable the old code again. So here's the old shader which worked. Right, we knew it worked. And then we're going to bring back that one. Right. So there's the full screen of the old render. So there's the old render. Then let's try the command visualizer that we've got. So this could, if this works, then it means perfect. So here's it's visualizing the commands, and it's doing, so when it hits one, I don't know how good it is. So you're going front to back. Command index is not, we really want the full, what we want to do is draw command start index. Draw command word start index, that one. It's shared that way. What? Because the problem is every tile had a different command index because it was the local tiles commands index. But what we want is this whole one here, really. No, sorry. What we want is the this one, the words, because that's shared the same across all of them. Perfect. Look at that coloring. So this coloring works here. So it doesn't work in the other one, which means, yeah, so these show each individual draw command. So the background is obviously a draw command. Yeah, the background of the button and each glyph that we're rendering. Hey there, Rohan, how's it been going? Ain't seen you for a while. No, I'm not sure what game we're going to be making yet. We'll get to that when we've done some rendering R&D, basically. So let's disable the let's disable that. But yeah, things we're gonna write. We're just at the end of this UI rendering work. We're just trying to optimize the shaders as much as possible, really, and just doing some crazy yeah, just trying to optimize the shaders. So we've rewritten the tile binning shader right now. And it seems to be doing better, but it's also broken stuff. So we're just trying to debug and figure out what's going on, basically. I don't know if it could be the new 0 thing. I'm not sure. Oh, come on, is this the right one? The right one. It shouldn't be read write, it should be mapped as write only, but still. Come on. Yeah, it should be write only, really. Not that it matters that much. Yeah, it might be better for the driver maybe. But anyway, so rerun that. Right, so it's got a white screen. Sorry about that. So we enable that visualizer. So it's broken, right? We've got a few visualizers. We know that the tiles are being allocated fine because we can visualize the tiles, right? We know that the heat map is working fine. So we can visualize the number of draws per tile. So the counter in there, which keeps track of the number of draw commands per tile, that's looking fine. Now the heat map for... Now the visualizer, which is a different color for each draw command, that one doesn't work. So it appears that the draw command information is wrong. Somehow wrong. Which is really annoying because it's a difficult problem to fix correctly. How's the baby boy? The baby's doing great. He's got a few little he's got a bit of some stomach issues where he gets a bit unhappy, but and trying to pass wind. But other than that, it's pretty good. Like we've been giving him some gripe water, so it should be help him with that. But yeah, he's doing great. It's a lot of fun. So yeah, he's super cute, and he's growing as well. He's only outgrown his little Moses basket we got him that he sleeps in, so I've got to assemble the cot soon. He's grown out tons of clothes, all that good stuff. So yeah, super cool. Oh, I'm putting in the wrong bloody place, aren't I? This is the problem. Alright, we got it, guys. We got it. We got it. Don't you worry. That plus that, right? This will be like 0 to 16, whereas this is a massive array filled with smaller arrays of 16. So it's like, imagine it's like a 2D array of like the number of tiles and the number of draw commands in a tile. So it's got loads of little draw commands arrays for each tile. So this start index needs to be in there. There we go. Because that's where it starts, and then the offset. So that'll be the fix, and we run it. Damn it, it's just a little bit off. What is going on? I thought the vision. Should we run the visualizer now? Yay, scroll wheel. Right, so we're still getting flickering with this. So these ones are flickering for some reason. And I don't know why. These ones are not even rendering, which is bad. Are we overflowing a buffer? Maybe. So we used to do a thing where we used to, in the old shader, say if it overflowed, stop doing it entirely. So what we should be saying is if the insert index is greater than or equal to the maximum number that we can store in there. So yeah, it's got to be less than. Right? Oh, um, yeah, but I don't think that's the problem because we're not fitting 15 or more in a space, are we? No, we're not, you see. So what's the problemo now? So we've reduced that by about 0.3 ms. I was expecting way better performance by doing that rewrite, but at least in twice as much as that, but it wasn't, unfortunately. But we can still optimize it further. Just got to work it out is all. So why would it flicker? What could be causing that? Um, so one way of doing it would be let's only draw the first set of Y's, right? So let's just say change that to 1.f. If the stuff on the left still flickers in the same place, then it's something to do with the position. I don't know. I don't know if that's true. I should really take a screenshot. Yeah, so we do the couple of rows, right? So let's make that 200. I don't know if that's right. Right, it was like so 3 or 4 down, right? No, it's different, isn't it? So are we in like an array overflow or something? So we're still, even with less, there's still issues. So even with rendering less, there's still problems. There's not really flickering, you're just missing glyphs entirely for some reason. Right. So it must be something to do with the shader. What could it be? So you're doing the atomic add. Which means it will be bigger than the number that actually in there if it overflows. Right, so maybe you do a sub. We can't be going over the maximum, right? Right? We can't be going over the maximum. Um Um, so this is pre-allocated. We can't be going over the maximum because we've allocated enough, like the max window size or something like this. So I don't see that being an issue. Um, huh. We can use a number of tiles in the end. Tile limbs X, Y, that's fine. That's the number of tiles, that's fine. This XY, let's rename it to tile X, tile Y for readability. Cool. Why is that one complaint? Cannot find tile X. Oh yeah. Cool. Right, so why could something be flickering or not rendering at all? It's a whole draw command itself is missing sometimes. That's the issue. So surely that would then mean that this thing is not running. Maybe it's not finishing in time and they're overlapping two shaders. Or yeah, so let's just quickly double check to make sure we've got all the right sync code. Right, so we've got right, so a read only on the draw commands, read only on the word. Yep, write only on the draw commands. Write only. We've got atomic in there now, isn't it? So maybe that should be read, write. That's the problem. That needs to be read, write. Because you're doing atomic stuff. So it'd be read, write now. Because you've got an atomic in there. So something's fishy on the AMD hardware when you do that, I guess. Right, that should be the fix. No. Right, so let's get the other ones. Here's the render. I think they're fine, they look it. So we've got, where did we get? Yeah, we put read right there. Okay, so read only, read write, read write. Yep. Then we got the read on those guys, so that should put a barrier in between, pipeline barrier. So you know, we've had that working before, so I don't think that is the issue with the pipeline barriers. So it's good to double check that though, because we did find a slight issue. The number of draw commands and the dispatch group size. So what's interesting is the background is never disappeared, right? Every background renders. And then here we're getting half renders, right? We did just add that new visualizer code. Did I mess up somewhere? It's if'd out, isn't it? Right, should not be in there. Can I delete it just quickly just to ensure that it's not my compiler doing something fishy? No, it's not. It's good. Right, so if that out, seems good. We haven't changed anything in here though. Would a real stupid way of discarding that as a possible idea be to sleep on the CPU for exiting? No. You can't possibly sleep on the CPU because you're making a command buffer and it's all chucked together, and you dispatch it, and you give it to the GPU and it does all the, it schedules it on its hardware. Yeah, that'd been a nice idea. Yeah, I'm talking about the sync thing, yeah. Like, you can't simply put a sleep here because this is recording into the command buffer and it's not actually launched on the GPU yet. It launches on the GPU here in the submit. And yeah, we clear the buffers as well. Yeah, we clear some buffers at the start of the frame as well, so not really possible. It seems like we're getting overlap. Are we getting overlap? So if we run this, you'll be seeing the overlap surely in the visualizer. I don't really see any flickering tiles anywhere with different colors. That's the problem though, isn't it? They might be the same tile coordinate, which means you're running it twice. Yes, so the problem is that the tile list is probably getting the same tile it's probably getting the same tile in there somehow. It's probably how it's happening. So yeah. So I guess we can do this, right? We've got printf, baby. This is how we're going to do it. We'll work out the tile. Printf to the rescue. So this one here, this tile right here. I won't move my mouse. Enable the visualizer. Damn it, wrong one. That tile right there. Right, so it's this one. So it's 0, 1, 2, 3, 4, 5. 5x 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 by 11. So here's what we're going to do. Right, we've got printf. So, pretty simple. Tile coordinate. If tile coord dot x equals 5, and if tile coord dot y equal 11, dun 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 dun, GPU hprintf found u. So if we see this multiple times, it means that it's being rendered twice. The tile's being rendered twice. That's a lot of times, isn't it? So clearly, we get multiple tiles being rendered. No. No. Obviously, you have multiple pixels. Shoot. And the dispatch index equals 0. Local index is you're the first thread. Yep. Try that one. Okay, so it only happening once. Damn it. Thought I had it. Because it seemed to make sense why some are flickering and some are half rendered. Can you have some weird color to make sure you hit the right tile? What do you mean? Can you output a weird color to make sure you hit the right tile? So we already visualized the tiles based on their color. And we chucked that out on the tile itself. Yeah, so you would see, yeah. So in the if we just write, that's true, to make sure we hit the right tile. Good yeah, that's a good thing. Yeah, so we should be seeing that blue tile. Where is it? Uh, oh, it's all the way down there. It's the wrong. Oh, good. Yeah, it's in the wrong place. It's just the wrong way around, isn't it? Damn it. No, it's cool. It's cool. That was a good suggestion. So we need to do. Wait, how many tiles we got going up? That's the question, isn't it? So 960 divided by 16. 60. So it's 60 take 11. Which is, damn it, brain, 49. Yes, I just did that. Right. Right, so it's not in the right place, is it? Cool. Right, so now it's only happening once. What is going on though? So the thing is, if I zoom in, it is just rendering the blue, and it does flicker in sometimes. It's weird. We're getting some race conditions, surely. So I guess we can now use this information to do some more printing. Like, so we should just be seeing that T, like, I don't know, what could we try and visualize, or what can we try and print out which would be useful? Well, you should just be seeing. Right, so you should just be seeing type. So that type should be. See, it's saying 9, then 6, then this, then this. That's obviously invalid information, isn't it? Um, um, UI shared, so we get to see the numbers. Oh, well, maybe not. So 9 is AABB, of course. AABB, then 6, which would be like a rounded expand. And the time when it flickers on, it's like it's missing. Oh no. They won't be in order anymore from front to back with the new optimization. That's the reason. Shoot, I know the problem. Right, here's the problem. So with this new one, they won't be front to back anymore because when they launch, sometimes these draw commands are in order, front to back order, and when I insert them into here, into this array, the one ahead of me could get in front, and when it gets in front, it's going to be put into the array ahead of me. So the way you get around that is you probably need to sort it. Which is not good. Can you put a barrier in? So you're doing 32 threads, right? If you put a barrier in, and say wait for all of them in my work group to get here, it'll tank the performance though, and then it wouldn't necessarily run in the right order as well, maybe. It's probably not prep. So when you insert them into this array, then you have to do like an insert, which is not the best because it can basically involve like a mem copy and shuffling things around. Yeah. Yes, this new version is slightly quicker, but it does. Yeah, it's a bit of an issue, doesn't it? Right. I'm just going to take a quick 2-minute break and then I'll have a think about this. I'll be back. Enjoy the tunes. Alright, welcome back everyone. Is this a 3D or 2D game you're building? So it's going to be a 3D game, but we're just doing some 2D rendering to start off with. When we got the UI done, we'll be doing some 3D graphics R&D. So that'll be the next thing we'll be doing. Right, so let's quickly think if we can solve this problem, but I don't think we can. So the issue is the fact that these threads could be, so threads run in lockstep, that's fine. So you get 32 all running in lockstep together. But the other guys outside of the work group are not running in order. Like they could possibly beat you. So the ones that run inside your work group, yeah. So effectively, if they hit the same tile, the one in front could beat like these are ordered from front to back, and I need this array to be ordered from front to back. But the insert index ends up being ends up shuffling them in different orders because the probably the work group or the dispatch group, whatever you're going to say, ahead of you, the group of 32 threads ahead of you, could be running one instruction ahead or something and beating you two here, and then insert into the array ahead of you. So, because it happens that infrequently. What happens in sets of them, though? Yeah, which means it's probably the work group thing that I was just speaking about. And it happens a distance apart, so it's probably that. So is there a way to sort of like enforce... It's probably an extension, isn't it? Execution entirely unordered, basically no effective tools of force order. Damn it. No! Subgroup memory barrier. So we've got memory barriers. Performs memory barrier. Enforces ordering. Right, so we could put barrier down. Should we try it? That might fix it. But it could also incredibly just bug a performance up. So I completely forgot these. So third party HCC, intrinsics. Add characters disappearing in my text rendering too, but it's single threaded. Oh. Yeah. Yeah. I guess there's many problems that, yeah, many ways that could be expressed, isn't it? Wave intrinsics or atomics? Right, here you go. So let's put one of these barriers in. We can always monkey around with it. So let's do a memory barrier. So this is going to, as my documentation says, waits for the atomic mutations operations for all threads across all waves in this to be visible. So control barrier and waits for all threads and waves. Ooh, we might want the control barrier. We can try memory barrier as well. Right, let's try this bugger out. So we want it before the atomic. Right, that didn't even help at all. Let's do it here. Doesn't help. No. So it compiles successfully as well now. Let's try the memory barrier and see if I got them, because I've not tested these out yet. Okay, that doesn't work either. Fair play. Okay, so I don't know if there's a way to make this bed actually work, which is a shame. Damn it. Insert into a list. Let's get the music back. Let's get some bit of Stoner Rebel out, you know. I think we've played all the next Johnson maybe like 3 times over. So let's do it Stoner Rebel. Um, so you're not going to solve the ordering problem when you insert back into the array, which is a big problem. So the old one. So I guess we can come back to the old one. Um, the old one. So let's bring it back. That's good. We're back to there, and also this can be right only now. Yeah. This can be right only since we don't atomic add into it. Good. Sehr good. Do you ever feel motivated, demotivated to code? What have I done? Oh, I put -1. Whoops. Guess my compiler doesn't like that. Shoot, what did I do? Oh, I did an 8x8 rather than 8x4. 8x4, my friend. No, that's clearing. Oh, damn it. Get far enough. What? Demotivated code. Oh, I should have put that to 1, that's what I meant. Sweet. Okay, so here's the old shader. It's slower, but it's fine. So I think we can try and do is like, let's take the common case where you might want to round the corners of a box, and let's just bundle. Let's reduce the operations down. Do that. That's the next optimization we'll do, because Sod's law, you want to round all the corners on a box, right? All the time, basically. Do it for demotivated code. Only when, see, it used to be a lot more when I first started. But you know, when you don't want to program something and it feels like an absolute chore, then obviously you feel demotivated. But the trick is to try and find an enjoyment in the thing you're programming, no matter what it is. Now, obviously, that is something that you do. Um, it's an instinct that you have. So, you know, if you don't enjoy doing something, it shows that you're not learning, right? Maybe, or some other thing where you know that this is a net negative to stuff, and obviously you don't want to suppress that all the time. But there's moments where you need to suppress that just to get on and achieve the thing you want to achieve. But you should always be aware of that feeling and make sure that you know that it's not actually a net negative in your life overall. But yeah, that's something where it can demotivate me at times, but I try not to. But I try not to get. But I've got much better at it over time of programming. Um, Stuff that demotivates me as well when I think too much about how GPUs are just terrible to program. Basically, you know how the Vulkan API is ridiculously complicated for reasons of tons of different ways of hardware works. How that stuff is kind of a bit demotivating sometimes, and however complicated it is, especially when as an engine guy, I want to suggest to people, hey, build your own engine, but then they'll actually use Vulkan. Probably not. Because it is a lot of work to understand. Yeah, these things sort of are a bit demotivating sometimes, but then I just try and focus on other things, and trying to do something bare minimum like we're doing now. We're trying to do it with compute only, right? Can we avoid all the triangle rasterizer stuff and do something decent? But we'll see. Big demote for me is arguing with my managers. Oh, I think they know better. Nice. Yeah, I luckily don't have that problem. But yes, that used to be an issue actually. Now I remember when I used to work at some place, my manager was an absolute like twat, and he would, I was just a new programmer, and he would basically just constantly say how terrible I am, and it's like, no shit, I'm a new programmer. You know what I mean? Um, just people like, he basically felt like he hired me so I could be his little like punching bag. So I was like, okay. And he would like try and do all this sort of like, he would try and make it seem like he knows stuff how it works at a low level by knowing what call stack is and interviewing people that he knows are cool, that if they don't know that variables go on a call stack, then then they're dumb. Like silly little stuff like that. Um, big motivator. Work on your projects, on your own projects. Yep. Do your own engine, object software render, make 2D game, then the address sucks. Okay. That's a good one. He was boosting his ego by shit on you. Exactly. That was it. I just one day I just sort of just got up and I was just said, thank you for giving me the opportunity, but I don't want to work here anymore, and I just walked out. That's basically how it went. Not the best decision apparently to do, but it was I had enough after 2 years, so that went. I just didn't want to be. I wanted to make sure that he felt like I wanted to make sure I didn't do anything in the wrong to sort of like, you know, get pissy with him or anything. To make him self-reflect, because the thing is, as well, is he used to get drunk. I didn't say this, but I remember he used to get drunk and then just like say even worse stuff, like you know, just yeah, just anyway, go in the pub on a Friday and just come back with more stuff. Well, not even that, just people thinking too high of themselves and screwing up. I mean, their own faults, yet. Probably made him manager so they don't need to deal with shitty code. No, this is the thing. This is the thing. He was the owner of the business, and he used to get drunk and program at like 5 a.m. in the morning or whatever because he was super excited about the project and check in some code which didn't compile. I'll get into the office at 9, get latest. Oh, something's broken, and then just like have to twiddle my thumbs sometimes until he gets in, or sort of fix it. Then he gets in, and it's like, you know. Um, so yeah, just that sort of stuff. Yeah, it turned out the best. Exactly, a lot of trial and error, but yeah. Ah, yeah, it was one of them. But yeah, those things are heavily demotivating. Yeah. Right, so we've got a slower version of the shader back because it works. Um, right. So what I want to do is, can we make? See, we've already. Okay, I want to make this better. this needs to be moved into the UI shared code because this is shared between CPU and GPU. Yeah, I could have did find and replace better, but anyway, I did it that way. Right, more of these guys. Let's go. Oh. Okay. What? 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 Uh-huh. Right. So now I also want to think, like, if I can put some, like, UI debug tiles. So that debug the screen tiles. This one is UI debug. I'm just thinking like, because you'd have to go to the correct point in the shader and find it, whereas you could just go to this header and just enable it, right? Visualize number of draw commands per tile. So you want to be like debug tile draw command heat map. Right, so there's a heat map you can turn on. This one. So they're all in the same place. Be nice, though, right? Be beautiful. Don't repeat the comments. Then the last one, or the other one is here. To visualize the commands. So you can visualize the commands. It's going to be lovely. It's going to be awesome. Oh, it is awesome. So we do get a little unique color per command. Nice. Cool. All right, what else is gonna go on? So there's another one as well where we can visualize. Right, so deleting the other shader. I know I put times this today, but we learned something. We learned something. So this other one is like run all the tiles, useful for benchmarking, I guess. UI debug run all tiles. Right, so that's a lot cleaner. All the debugging stuff is here. We can just recompile it. Done. Cool. Right. Test, test, test. So let's do an optimization. The thing is when you do an access line bounding box, most of the time you just want to round the corners. So let's see how much better it actually makes it for a full screen worth of this. That's going to be the test, right? Whoops. Yeah, I don't know why it is bad people are really good at hiding about climbing to high positions. Maybe it's just because, obviously if you're an owner of a company and you have money, if you're a bad person, there's that thing. But, you could just be a good person and then, it's 50-50 really, isn't it? Two options. Or is a middle ground, right? But then you've got the type of person, I guess, who stays in a company and climbs the ropes over the years, and that person is just a bad individual and maybe can't get a job anywhere else. Or maybe someone just simply gets put into a position that they're just not good at. Right? They could be good in the lower positions, like maybe, for instance, programming, but they just might suck at being a manager, and then they get put in that manager position somehow. So yeah, I guess, yeah. Yeah, well, they just have a characteristic exactly, which is just poor. Yeah, it's really nice when you have a really lovely, lovely manager. Really great. Yeah. Right. So what I want to do is, so let's try this optimization out, right? We're not going to do any, we're not going to do anything, right? We're just going to pretend. Yeah, that's another one. If you become a manager, you can't code anymore. Yeah. Well, actually, what's interesting is my boss actually gets a lot of time to program still, but he does have those moments where he just sort of like ends up talking to everyone for a day, and yeah. Right. So remove this rounded expand. Then what I want to do is simply. No, but I can't do it in the shader. Right. So it's you're going to be like reading a word off. Right. So let's just see. Okay. Let's just see how much. By removing the rounded corner, how much does it actually help? So we've got about 0.87. So if we don't round the corners, it's 0.61 for a full screen worth of rounding corners. So that is about, oh, it's about 30. I don't know, yeah, it's quite, it's quite a bit in it. Yeah, it's quite a high percentage. So what we could do is we could pass in the rounded thing always and just avoid doing the extra loop. Yeah, so it's a problem with making something flexible, right? Is most of the time we probably just want to round the corners. Anyway. So we'll push a word. So we need to do that for both the oh, come on. And the clip. Right, so we've uploaded the word there. Very good. We might have to change the dimensions, I'm not sure. But we could probably do it in the shader. So ABB. So we'll read an extra word off. This be the radius. One word. So we basically want to like min the half size with, sorry, max the half size with the radii, or max it at 0 pixels. Is that right? Yes, you say half size equal max s f32 times 2, half size and radius. Then you want to basically do sub. You could just max it at 0 as well, but anyway, sub f32 times 2, sub s f32 times 2 radius. Cool. Then you want to essentially just like take away the radius from here to round it, right? And that should be what all we need really. So we just got to change the we just got to add these in here. So these would just be 0, where we're not really doing that here at all. But then for the cases where we are going to do it, Um, it was around radius, wasn't it? Right, there we go. So let's try that out. So it was at about like 0.8, weren't we? And we went down to 0.6 on the other test, but this is going to be the real test. So yeah, that one went to 0.6 and got the rounded corners. So that is a good optimization because we are going to be doing it all, like, you know, the game's UI is probably going to be rounded. But I guess if we're not, we can just remove that. But yeah, it's a good optimization there. The Peter principle, what is this one? Oh, concept where management observe that people in a hierarchy tend to rise to a level of respective incompetence. Employees are promoted based on the success in previous jobs they did until they reach a level where they're no longer competent. And not because skills in one job are not necessarily translatable to another. Right. Yeah. I guess that makes sense. Yeah, it's kind of what we was kind of saying, really, wasn't it? Yeah. And someone had to name it after themselves. It could have been the Henry concept. I missed that one. Mm-hmm. Right. Yeah, also times change, that's another thing. Yeah. Yeah, but sometimes that's useful though. To sort of have older knowledge. Henry principle. What would the Henry principle be? That is the question. What would the Henry principle be? Has anyone got one? Right, so we optimized that shader, brought it down. Should we try and see if we can optimize the binning again? So that's a common case we're going to be having. Or anything else that we can quickly optimize off the top of our faces? Off the top of my face, what can I do? So the tile bending does 8x4. Goes over all of the commands per tile. You're probably gonna get shared. Like that's gonna get shared between. Like when you load this in, it's gonna get shared across all the threads in your wave. So there is some sharing going on anyway. So it's not like you're loading it per thread and getting throttled, which is fine. But we could also throw a control. See if we throw a control barrier after everything, and it maybe. See, I forgot how control barriers work, but do they work on like? They work at a level where it's every group. But then you would fill up your CUs with a bunch of these shaders. But if you get them to wait there, would they reuse the the cache basically, right? Would they reuse the cache of the matrix? No, didn't do anything. I think it might have made it worse. Right? Maybe. Let's see. Yeah, kind of made it. I don't know. Let's try memory barrier. Trying some ideas out. No, ain't getting any better. Yeah, it's the same. Damn it. I'm trying to do a control barrier, isn't it? Oh, maybe. So it's all the ones in a group, but not in your dispatch, I think. Yeah. So what happens if we did this? Make it 8x8. Or let's do 16x16. So it might be on that one. Just throwing stuff at a wall and seeing if it works. Oh, yeah. So this one is 16 by 16 now. So I think it might be the local groups. Like your local... So sorry, your dispatch local. It's all the waves inside that sort of group. That's it, all the waves in a group, right? So if I've upped it to 16 by 16, by putting this barrier down, I think it's all the waves in that single group of 16 by 16. So if it's like a native 32 threads, that's 8 by 4 type of deal. So let's see if that helps. Right, that made it slightly worse in terms of performance by upping it to that number, probably because it has some dangling off the edge or something. If I move the control barrier, it makes it better. Back to what it was basically. Okay, so the control barrier did nothing, but it definitely seems to be on a local, based on this local dispatch size. So, okay, learn that, then that's good. Let's put that back. What it was, okay. Henry Rose is a cool name for a game, maybe your game should be called Henry Rose. There's also a movie called Hardcore Henry. I never watched it, but it sounds super cringe. You know, it's a first-person shooter where this lady gets, kidnapped or whatever, and she like screams Henry, and Henry's running around trying to save this lady, and yep. So yeah, I've never seen it, but maybe I should watch it. It'll probably make me cringe super hard. Sound like someone who's just seeing cool Henry, yep. Just no scoping people. Ah, Hardcore Henry, exactly. Maybe that should have been my name. But yeah, I was soon to find out the Henry principle, whatever that would be. What could be the Henry principle? So where could be the bottleneck in this shader? Maybe that you've gone over all the commands. Is there a way that we can reduce the number of commands somehow again? Well, you have a pre-pass, right, where you sort of bin into even larger tiles. 2 level of binning. Does that sound insane? That's probably another optimization, right? So what you do instead is you have your screen. It's pretty insane, actually. So you have your screen, right? And you bin them into even larger tiles. And then you can basically go over the bigger tiles and then put them into the smaller tiles, and then that's it. So then that would mean you're going over less commands per tile in the end of it. That could be one way of solving it. Because we've got like 2,000 draw commands right now, which is probably something which we could have at some points, and that it makes it goes up to 2 ms. That's probably quite a bit for a UI, right? There must be a way to make that better. It's a lot. It might be the matrices that we're doing. Should we try and see if So say if we did another version and removed the matrix stuff from it entirely. I just want to see how much of an impact this has on it as a whole. So you would do something like tile center. Let's just say it's the tile center in, because that's what we're trying to work out, right? And that'll just be this. So the rest of this garbage can go. And imagine if we just did that. Maybe be half dims. Oops. We need to pull that word out, damn it. Shouldn't be too much of an issue. 6. Right, let's try that one. That dropped only by a little bit, so the matrix is not really adding too much at all. What happens if we didn't do this if statement at all? But then what would the for loop be doing? Actually, be doing absolutely nothing, isn't it? So the fact it's going over all the tiles. Okay. This can't be adding much to the shader time either. So this is going over 2000, which means you got long-lived shaders. So because it's a long-lived shader, potentially that's part of the issue. If you could split it into see, the benefit is you're doing one tile per thread. But if you multi-threaded it for the tiles, which we did before, you need to make this atomic, and then the out order insert set doesn't really work. That's what we had the problem with before. Have you used a BVH tree? Maybe. Yeah, I wonder how you do that on the GPU though. Could be possible. Probably possible. Working for 5 years on my project in 5 hours on Project Rust. Now it compiles. I forgot what I was doing to fix in the first place and I have no idea what I did. Yeah, the borrow checker sometimes makes you refactor stuff quite a bit, doesn't it? Like wrap stuff in structures and things. Whoops. Right. Okay. So a way we can also fix the problem maybe. Well, the text is all the same color, isn't it? So if the text is all the same color, why are you doing a different draw command for each one? They could technically go under the same... Oh no, they can't because they're being colored based on the glyph sample, aren't they? Yes, that wouldn't work because it colors based on the whole box. So that could have reduced the number of draw commands, but maybe not. See, if the application ends up being, say if you have heavy text elements, you put in, yeah, that ends up being a lot of commands, doesn't it? Because you can't color individual elements like of a draw command. It colors the whole command because you're comprising like one shape. That's the idea. When I mean draw command, I'm not using the same terminology as standard because we're using it all in like I've kind of like used the terminology for my UI system. Like a draw command is like I've had to run the other thing. Shoot. Two seconds. Yeah. So you're like, yeah, you're based. That's a good thing you're doing. You're batching all your triangles into one buffer and just doing one draw command. That's really good. What we're doing is we're doing it via compute shaders. So we've called a draw command like something which like means you can put down a couple of shapes and do these operations on them, sign distance field operations on them, and then come out with one whole shape at the end. So this has got two circles and a box. Yeah. Yeah, it's pretty decent way of doing it. Yeah, and you sort them via, yeah. I've done one of those before, it's really good. This many draw commands isn't that bad, it runs pretty okay. It's quite UI render heavy, but the binning, yeah. Binning is still quite... So I wonder what we could do for the binning. Make this better. Yeah, so the way I've designed this is it's meant to be a super flexible renderer. So you can do some crazy dynamic stuff, like some really weird like game UI stuff. And when we start the UI, like the UI system code, I want to make sure that there's like I'm not sure how much I want to go into sort of a very general UI thing. I want to maybe expose a lot of ways of doing stuff custom. Um, it's going to be immediate mode UI, but I want to kind of expose a lot of this so it gives you the room to just like do some little custom things easily. Um, but yeah, this is the trade-off, right? Flexibility and the cost of performance. But I'm trying to make sure that if we want to do something simple, it's not going to bug a performance up. And by the looks of it, just doing a bunch of text is going to be quite. It's made the binning slow, but maybe we should try the two-tiered binning where we bin it. We have half side bin. Should we see if we can whack one of those shaders in? I think we can do it, right? Literally copy paste the shader. Wait, can we reuse the same shader? The problem is we've got constants. It's just the tile size, isn't it? And the different buffers. But yeah, we could literally have a two-tiered system. No, but the second one would go over all of the. We get the draw commands from here. Yeah, you need to copy paste the shader. So if you have like a two-tiered binning system, um, you are doing probably less copying overall. Um, hmm. But obviously, if stuff's full screen, you're copying that thing a lot. That's the downside to that system, is you're copying it a lot. Plus, we've taken up more memory. But it's a way around the problem. Um, what other ways could you do it? Um, But the problem is that number's just way too big. Hmm. Hmm. Yeah, so we did like a two-tiered tile system. It would probably be good for these situations. Right, let's do it. Let's see if we can just whack this thing out. So we'll call it like T0, T1, two tiers. So the first one is going over. So you got this thing called a tile. So we could call it a chunk, right? So the chunk is maybe, I don't know, this number got a tune. But let's say it's 256 or something. Like it's massively bigger, maybe 512. 512 is probably a bit too big. We'll see. So you have like a chunk. So you have a chunk, we'll call it chunk binning. So swap out the word for tile for chunk and away we go. So this one is just going to be and then we need to dispatch on the chunks. Interesting. Right. Tile, chunk. Tile, chunk, draw commands. That's the output. Do we need a chunk list? Like you might not have any chunks which actually got stuff in, but I don't think it's good. There's not going to be that many chunks that's going to be worth it. I think. So it should just be that and the chunk dims. So now the other thing is you want the draw commands. You want chunk draw commands. And then you want draw words. So that's your input, there's your output. Chunk draw commands count. Good. Well, no. Okay. Right, we got this. So if we bin them, right. So every word that says tile says chunk. Chunk dims. All right. So this one is fine. So we just put it in the chunk thing. Yeah, then we store the number of draw commands in a chunk at the start of the array, right? So we knew how that one works. Now the tile one is the one that is changing. Wow, looking at my dream. I'm new here. Hey there, Hungry Bear, welcome. How's things going? You into C and C++ programming, into graphics? Um, right, so this one is going over chunks, right? So we want to get the... Wait a minute. This one's going over tiles, but we need to know what chunk you are in. And then we need to fish out a chunk. So based on the tile, based on the pixel coordinate, you could probably round it to the nearest chunk, or you could probably just do a division based on chunk size and just get a chunk. coordinate, right? So you want to do like a chunk. We need a chunk index, isn't it? Is that right? Chunk index, which would be, it will probably be it will probably be dispatch index. So this is going over every tile. So divide it by so you need to know how many tiles fit in a chunk. Tiles per chunk. I'm trying to learn C, but the program I'm trying to learn C is too steep. I'm lost. I'm trying to build simple shell and Monty interpreter. By next week, C is fun. I only ever get nice, very cool. It's very, very good. I'm glad you're enjoying C. Like C is really great. Simple language, has all the stuff you need. Go full ham, you know. But yeah, has anyone got any good suggestions for a hungry bear? You can also join the Discord if you have any questions. There's tons of good people in there, including myself, who can help you out. If you ever get stuck with stuff, feel free to have a gander. Dispatch index is the index of the thread group wavefront. No, dispatch group index is the thread group one. And it's not necessarily a wavefront. Only if you directly map it to a wavefront it is. Because it could be multiple waves could be running in a dispatch group. Like if I were to make this 8x8, that's 64. So it needs 2 wave 32s to run to 2 wavefronts, right? Do I need chunk dims? Why? What do I need? I need a chunk index because I need to get into the chunk array. Need me some chunk dims. So it's the chunk binning, that's all fine. Tile binning, chunk dims. Right, so you get yourself a chunk. Hopefully this is going to be easy to do. So you need to work out your chunk start index for where the things are stored. Yes, the number of draw commands that you can store per tile. So per chunk. That's a different number, isn't it? So see, I don't know if this is worth. Hopefully it is. Yeah, so save you like 2048. I don't know if that's way too much. We'll see. Good. So this lands you on the chunk draw command start index. Fantastic. Here's your tile index. Right. So your draw commands that you're using now is the chunk draw commands. Now it's a bit like the way this one worked in the UI render, where we stored the I want to do something like that. To chunk, draw words count, chunk. Yep. So we're going over the smaller array, so hopefully the tile binning is faster. Fingers crossed. As long as the chunk one is... Yeah. Right. I see, if you're not on AMD... Yeah, that's true. It's true, Mr. Shelby. Well, it depends, right? AMD can run in Wave 32 as well. It depends, right? And yeah. Maybe do that then for Discord. Any recommendations for beginner projects that get used on pointers and libraries? I don't have any myself because I've been doing it for so long now, and I just don't really suggest this stuff often enough. But other people might have some good reading material. If not, ask me on the Discord if no one else is here. Yeah, yeah. GCN was Wave 64, wasn't it? Then RDNA has a dual compute unit which has two Wave 32s together, which can run in either or. It's good. It's cool stuff. I like it. I like that design. It's pretty sweet because Wave 64 is quite useful, but then obviously Wave 32 is better sometimes, or most of the time, I think. Um, so get your draw command. Let's go for tile. Then you bin that in the tile array. Bloody magical. Put in the tile list. Fantastic. So this chunk list shouldn't exist. Right. This is getting good. So, where's the count at? Good point. That's chunk binning, tile binning. So we want to fish it out from... Let's do it here. Chunk, draw commands count, fish out from the chunk words. Tile binning start index, yep. UI chunk cap, beautiful. Right, so this is where the fun begins. Now we've got to do it CPU side. We've got to introduce another shader. We'll copy paste this guy. So tile gets replaced with chunk. So this needs a new array called the chunk draw commands. That's the output. Then don't need chunk list. We need chunk dims. Chunk dims is rounded by chunk size. Beautiful. We also need to replace this tile with chunk. Good. Chunk. Eight by 4 chunks. Good. Now we need to make this new buffer. So go to where the tile buffer is made. Duplicate it. Go to here. Call it. Duplicate it here. Call it chunk whatever. Very nice. Tile. Chunk draw commands. So tiles capacity is, so we want to do like chunks capacity. So chunk size, chunk, and cool. So that's all in there now. So we need to make sure we fill out this buffer, like this one needs to get sorted out now. So we use the chunk draw commands as input. So we've got to make sure we get the right actual array in here. So it's chunk draw commands. So the chunk binning does a larger binning, and the tile binning is obviously smaller, and it uses the chunk draw commands buffers. So hopefully it filters it out enough. Fingers crossed, right? We also need some chunk dims. Can't go anywhere without those chunk dims. So let's just double check and make sure we've got all the bells and whistles. So chunk, draw commands, draw words, tile, draw commands, list. Yes, that's right. This one is draw commands, chunk. So it's 3 buffers. Yep, 3 buffers. Very good. Plus the other 2 things here. Fantastic. So it's looking good. I don't know what else will be. Oh, I nearly synced on the wrong resource there. That would have been good. Yeah, I like 8x8 groups and so on. Yeah, 4x4x4. It's a nice number, right? 64. Not in that wave 32 nonsense. But yeah. Okay, so I think we're good. In the render, we didn't change anything, right? We didn't change anything here to do with chunks, right? I didn't see any chunk anywhere in the actual render. So we don't care about chunks at that point, it's just tiles. So okay, so I'm just gonna double check the chunk shader again, but I think we're all set up. It compiles, right? So it must run. Guaranteed to run. So the chunk binning goes over 8x4 chunks at a time. They're 256 right now. We'll see. We'll change the number around. We've probably got to make it a non-constant number when we release it. Because depending on screen resolutions, you want different chunk sizes probably. I don't know. We'll see. But maybe not. Yeah, and when it gets so big, you want a third tier, but no, it'll be fine. Chunk index. Yep. So you get your chunk in center position in screen space. Very good. You're setting this index to 0 because you're ultimately trying to so you're trying to go over every single draw command and insert. See if you go inside the chunk. If you're inside the chunk, insert it into the array. You've got 2048 of those. Fine. Yeah, it's looking good to me. The next one is the tile binning. We get the chunk index by doing dispatch index y. So this is a tile index. So we're dividing it by 16, I guess, right? That will get us the chunk because it will collapse down. It will truncate, wouldn't it? And that should get you your tile index. And then you're going to use that to read out how many draw commands are in your chunk. Then you'll go over all the draw commands in a chunk and fish out the. What is that? Chunk draw commands, my friend. That's a copy paste issue there. Good that we called that. Do you have a library you like for data structures in C? No, I just hand roll my own. Yeah, so if you go to the VOD channel, we have every stream on there. And you can just see us hand rolling it all within a few streams, really. I think they're like around 10, sort of like that. um, yeah, we just hand roll them per project basically. The way to go. Because you want specific implementations for each project, basically. You want the control. Fish up the words, add to the tiles. Right, I think that's looking good. I think though that okay, yep. Right, so if the GPU crashes, I'm sorry. You've been warned. So hopefully it doesn't crash. Right. So we're only getting a couple of chunks rendering. The rest of the chunks are not. For some reason it's just these two. It's incredibly variable. The UI render is taking bloody long. But the chunk binning is quick for some reason. That's even quick. Well, I don't know, it's about the same speed, isn't it? Yeah, it should be for this one. So why isn't it working then? So we can put the visualizers on, because guess what? We've got these lovelies. So we can debug some tiles. So apparently the tiles are working fine. That's interesting. Right, we get the tiles. What about the heat map? So the counts per tile, are they still there? That's not looking good, is it? So the count per tile is clearly wrong. The count per tile is clearly wrong. Why is the count per tile wrong? Tile. Chunk size is looking good. Chunk size is looking good. Your input buffers, yep, that's good. Sync code is fine. 8x4 based on chunk size. 8 chunks. Wait, why are we launching times by 8? 8 chunks at a time, isn't it? Yeah. Yep, it's fine. You're doing 8 chunks across. Wait a minute. Yeah, that number's fine. So it's 256 times 8. 256 times 8. And you're dividing that by what was the number? Is that 1? Yeah. Okay, so you obviously just get 1, isn't it? And that makes sense, right? Because you got 256 chunks. So yeah, sizes. So that should be fine. So it's binning them fine. Probably. There's your draw command words. Is this used anywhere else? This do we do anything special with this? I don't think we do. Right, so the tile binning takes the draw commands in, the draw words in, which is shared anyway. It's fine. So they're read only now. That's the output. That's another output. Chunk dims, yeah, tile dims looking good. read only, yes. Write only. Yes. Write only. I'll read write, yes, because it does atomics. Tile size. Right, that's good. Launching parameters. Looking good. So I think the outside is good. Although, so let's check the inside again. So I think the tile binning. This takes the tile index on the screen. Sorry, chunk index on the screen. Yeah. I was thinking about the other shader. Chunk center position seems good to me. Yeah, we can't really debug this too easily right now. We could probably debug visualize the chunks. We could probably debug visualize the chunks. How do we feel about that? How do we feel about that? Divided by UI tiles chunks. Called tiles per chunk. Right, let's enable this new guy. Right, those chunks look a little bit off. So why is that? They should be square, right? This could be a big help into understanding why. The number of tiles per chunk. That should be 16. Is it 16 times 16? No, is that right? Was it? Is 16 good? Yeah, so tiles per chunk. So that's fine. So we divide that by 16, it should get truncated. What's uCore.y? That's just the output. Yeah, so we're just coloring it based on the chunk this tile is in. Are we getting overlap? We get an overlap? Huh. Brackets. So that could be the reason why stuff is failing. So obviously the coloring is really terrible around the edge. We could probably make that better, but it's fine right now. These ones, it's because they're like one time, like we need to kind of offset them by one, basically. We can make the coloring way better by essentially just doing like this. Same for the tile one here. So we're going to do this now, it'll look way better. No? You lied to me. Plus one tile. Oh, 8 chunk. Oh, plus a tile plus do a roundup. For this case, it's this one. Why are you getting... Oh, why is it getting that way? X plus... Feels like you generally want y plus x times... plus x. Maybe that's it. Yeah, maybe that might be better. Should we try that out? Not multiply. Yeah, I'll try that one out. The problem now is the multiplier is missed. This code hurts your eyes. I'm sorry. Debug code is fine. Much better. Thank you. Right, so the chunks, these are the chunks we've got that we're sorting the commands in. So that is fine. So the problem is actually we didn't do it that way. Just debug visualize the tiles. 1 times 2 is 2 times 1. Ah. Yeah, are they same diagonal? Here's a pattern. They're diagonal though. That's the issue. Yeah, you go diagonal though, right? Oh, you're saying multiply it by the large prime instead. So what you're saying is just put the plus in. Oh, shoot. Right, we should be back now. Hopefully. Alright. Is that good? I don't know why. I don't know why that happened. We were just changing the debug code and then it was like, I'm gonna throw a crazy... Wait, what happened? That crashed the GPU. Like, we didn't change anything. Okay, I think it could have been the fact that we hit a random situation. Like, it's the way the memory was, or something like that. Yeah, GPU crashed. So this isn't a problem because it's just doing fract. Right. Shouldn't be hitting a GPU. Problem. So anyway, I think I didn't put the brackets around in the right place, which is why the chunk, the system is something's wrong, right? So when we do the tile binning, when we access the chunks, we do this. We need brackets. That's the problem, because the visualizer code wasn't working. Thank you, thank you. Good to be back. So, in terms of this, did I disable the visualizer code? Right, so let's re-put the visualizer code back on. It should have stopped every time. Right, please don't crash. Good. Right. So let's sort this out quick. Put plus in there. I don't know what I did. Then it just strips. Not good. That's not decent. See, if you did an XOR, you'll get like diagonal when you. Not good. Yeah, thank God it didn't crash. Ooh, yeah, I think the multiplier is the best we got. Unless we've just got to have like an offset on these. See, let's try the debug tiles. Let's make that one the plus. That still strips. It's a little bit different though. Yeah, so this is what you would do for like a random number generator, isn't it? Hmm. Um, but yeah, I don't know why that would be. Let's just leave it as multiply for now. But yeah, I guess we could fix the problem just by doing this. Offset by a tile. Yeah, so now we don't have the dodgy edges. So that's even better. So this one would be plus 1 chunk. Plus 1 chunk. And that's the chunk rendering. Debug rendering. There you go. So these ones are a bit weird. So it's bottom left aligned, right? So you fit 5 chunks in. So why would that chunk color be different? Like, why would it be the same? Because you don't witness the same thing for the tiles. Oh, you do there, down here. It does have a bit of a weird pattern every 4 or something. I don't know. Anyway, ought to be good enough. Right, so what's the next thing? So we got a crash because we disabled the debugging stuff and we had something wrong. But I think we've fixed it now, so we'll try it. Please don't crash GPU. Alright. We're lucky there it didn't crash the GPU. Okay, so let's read what's going on. So it's probably the tile bit. The tiles are fine. It's something to do with how it's writing in the draw command. What is it doing? Um, so chunk draw command start index is draw commands cap. Good. Min that there. So it runs over all those. This plus that one. Sensible grabs that. It needs to start on 1. That's the problem. It needs to be upped by 1 like we do in this shader here. We up the start index by 1. Because the first index stores the counter itself. So you don't want to be using that one as a draw command. See, the first one stores the counter and we min it with the maximum just in case. We want to move the start index by 1 to shift off of that counter, and then we can start doing draw commands. Good. Right, so fingers crossed. Oh yeah. Right, so this one isn't going to run faster by much because it's not really binning. There's not a lot of draw commands in the same chunk, right? So chunks are massive, tiles are smaller, right? And pixels are obviously the smallest unit. So this one isn't going to get much of a difference. It's actually the same. Wait. Tile binning. How quick was tile binning before? I'm not sure how quick tile binning was before, actually. But yeah, yeah, it's not massively slower if that's true. But we're not going to be having that as a UI probably. But yeah, we kind of want this code to scale good. So hopefully it scales good. So we've got another test. So we're going to enable the other test. So here we go. So we're going to splat buttons all over the screen. How good is it? Right, so this now is saying the chunk renderer is taking... So we've got a white background now. Why do a white background? We shouldn't be having a white background, but now the chunk binning is taking 1.5 ms. But the tile binning is small. So that's interesting. Tile binning is small. And then why is the UI render taking super long? What did we change to make it? I thought we made that was really small. Is that running over? What is that doing now? So there's something wrong. So maybe the chunk binning is not good, but there's something definitely wrong with. Why is your UI render taking 3 ms? Like when we last ran it, it was a lot less. So it's probably got. So we can run the heat map stuff because that's the easiest thing to do here. So let's do the heat map. So that's the same across every tile. That's not correct. That should be different. Let's visualize the tiles. Oh no, it's not good. It's not a good one. Right, so this is every draw command. That's not the same anymore. It's around 0.6. Thank you for remembering. Yeah, I remember it being something like that. Rings bells. Right, why is there a background? There shouldn't be a background. So it's definitely reading from the chunks correctly. I'm concerned about, or from the files correctly. I'm concerned that it's just too, like it's definitely too big, right? Because we've done this one and outputs the heat map. Oh no, this one outputs the heat map. And it's obviously fully red, basically. How does it store it in there? How does it store? Yes, technically it's 15. This heat map is a little bit off. If you take one. Yes, it's fully read. So it's saying it's got a full set of commands. So this thing that it's reading back from here is wrong. So when we're doing the tile binning, we should be going over every chunk. Sorry, every tile. It should be getting the chunk index, which is the same stuff. Let's figure this one out. Where's the chunk visualizer? So here's the code for that. So it's tile coordinate y, which is that one, divided by, yep. The +1 is for some other stuff. Times by chunk dims x. I realize it's not getting an index actually, is it? Anyway, whoops. Right, that's fine. Times by the number of chunk dimensions along the x-axis, that's good. Overflow. Yes. Do we not catch oh, we do catch overflow. We don't store the count in the start of the array. That's why. Whoops. The end. Store the count in the array, so it's chunk, 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 chunk. So at the start of the array, we're meant to be storing the number of draw commands we came across in a chunk. So it's actually had a number in there for some reason, and it was quite big. So hopefully that'll work. Bearing in mind we should be at +1, that should be fine. Right, let's try that. Right, so the heat map works fine now. Beautiful. That heat map is looking good for the stuff we have. So there we go. So that's correct. So in terms of speed, I think it went slower. So the tile binning obviously went dramatically quicker. Well, and the chunk binning that we introduced. Wait. What was tile binning? How many MS did that go to? What was it back in the day? I don't remember. We have to wind back on the stream. Was that 3 MS before? It couldn't have been. No. It was 2 MS in total, wasn't it? It was 2 milliseconds in total. That was it. Right. So we are. This used to be 1.3 MS. Shoot. The chunk binning is actually quite slow. It's slower for some reason, and this because you got to go. You would have thought it would have been less. So should we play around with the chunk size? So the problem is along the X and Y axis, you've got a bunch of wasted threads doing nothing. Because the chunk size is too big. So if we do 128, you might fit more in. So now that's gone down to 1.3, which is basically what we had before anyway. Then we did 64. That's still 1.3. We're not getting any returns there. Which is not good. What about the dispatch must be fine, right? Yeah, see, we took chunk dims. That's probably the right number there. Do a divide round up on the chunk dims. It's probably the right number, but I'm just doing it just in case. Plus it's more flexible, I guess, if it's based on that. Yeah, it's the same. Alright, change the other one around just as well. BC tile dims. Right, so that's a shame. Um, hmm. You would have thought by running less threads in total. With the same long for loops. Would be faster, but it's slower for some reason, and I don't want to. All right, 2 seconds. Got that wrong. Oh, in the wrong way. Shoot. I don't want to sort of like. I want to just make sure I've exhausted every sort of thing with it because before I undo it though. Because surely it should be faster, right? You're running less. Like you should be running less invocations of the shader. You're still running over the same amount of data, but it's less invocations. Right, I know why. The tile binning could benefit from the fact that there's other. They could run multiple tiles and share in the CU. They could switch out to another invocate. Like this one's only running 32 threads at most, or whatever. Yeah, I know what's happening. So this one would have been running, like when it was massive, it wasn't running that many threads. So it was one. It was essentially like one compute shader running on a compute unit. So what was happening is it couldn't switch out to any other compute shader and do any hiding with the latency, basically. So with this guy, it's able to switch out and hide the latency, I guess. Yeah, not enough test buttons. We need more test buttons. We need transparent test buttons. So yeah, I think if I make this 16 and this one 8, I don't know, maybe this one 32, will we see an improvement? No. No improvement. That's all. So okay, I guess the chunk thing is not good. I don't, because you're not able. It just isn't. Okay. And we're definitely going over the number of draws. If you go outside the chunk, this is in chunks, and this is a chunk coordinate, right? pretty standard stuff. Yeah, I think we just gotta. Yeah. Mess parameters tweaking. ML. Not really done any ML. Right, so this is what we're gonna do. Just a massive set of undo. To about there. Luckily, I can undo between shutdowns because my Vim remembers file history for a long time apparently, and preserves it between sessions. Right, so we just deleted that one there. That's good, and this one. Okay. So I guess we learned some stuff today. That was a good learning session. Should we try and run it? There we go, we're back. So I guess the thing is like we'll just, when it comes to shipping the game, we can try and optimize it more, very specific to what the game is. But in terms of, filling the screen with 2,000 draws for UI, which I don't know if I'm going to be doing, maybe. It's about 2 ms. The tile binning works. Could we maybe try and change that number? Wait a minute. We're running by. That's per pixel, doesn't it? Chunks. Yeah, I don't know if that would have. Yeah, because I did have that thing where the tile binning could have been ran number of tiles per chunk. But then that would have just made the tile binning maybe faster? No, it was fine. Yeah, no way making that better. Have I tried constant expression thing in C plus or C23? No, not tried that yet. I'm not sure how good it actually is. Because the C++ one does lots of stuff, and I don't know how many of the stuff the C one does. I've not bothered reading it yet. That's the thing. 1.3M. All of that. Auto command plus MKView. Not sure I've ever heard of that. Yeah, specs are also the words, reading them and understanding them is just ridiculous. Right, this one I want to do is try and increase the tile. We played around with that, didn't we? We tried increasing the tile size to 32 and it was like, nah. So that increased the time of the render. And we go back down to 8x8. That's just going to massively increase. That should decrease the render a little bit there. For some reason. Huh. I thought selecting 16 by 16 made it better. So 0.6 that one is. Wow, it decreased the render by... Yeah, made that a little bit better. Fair play. But yeah, there's probably something we can do over time. I just got to figure it out. That can bring that tile binning down. Just got to work that one out. Or maybe there's another way we could bin draw commands. We'll see. Right, so I think that would be doing it for the UI rendering. We've got a nice flexible renderer. And now we can. Now what we can do is decide on how we want to actually put UI widgets on the screen, basically, and how we want to do all that sort of stuff. So in the coming streams, we're going to be doing. Well, the next stream we'll be doing probably sketching up some how we want the API to be, like how to use it, like usage code, and then we'll probably start implementing it and stuff. Right, let's find someone to raid. So yeah, the next stream is on Tuesday, 6:30 p.m. GMT. I should rate Christoph. He raised me sometimes. Cool. Right, thanks for coming, everyone. I'll see you on Tuesday or Thursday or something. Yeah, thanks for coming. Yeah, you should start streaming soccer. You should do it. Right. Have a great start to your week, everyone. I'll see you on the future one. Thank you. Bye.